Hey, what's up guys? A request to all the audience and viewers of this video that before skipping to the main content of the video, do watch the introduction part because that is basically going to be the explanation of what you are going to witness in today's video. So, today's video is not actually a tutorial, but in itself one complete course wherein we are going to model one complete structure in Revit architecture. But before that, I would like you to give an insight of this course, Master Diploma in Revit BIM, which is a combo of architecture plus structure plus MEP, of which I am the tutor for the architecture segment, and of which one complete session has been conducted by me. And I would like to announce that the next session is going to start from Monday, that is 25th of November. Okay, so today's session is going to be an introduction that what all I'm going to cover while teaching you this course and what all you are going to learn while pursuing this particular course. And that I'm going to demonstrate while giving you a live example wherein we are going to model a G+3 residential villa, and that too on a slopey terrain on a hilly region on a topographical site. Also structure, which is altogether a different template file of Revit and will be dealt by a different tutor, but I am going to show you that how can you incorporate basic structure, that is the beam column sizes and its location, while working on an architectural template. And it is going to be definitely a tedious and bit time consuming, but since I'm exactly going to follow the same process by which a structure is elevated on site, and I'm going to also lay focus on, I'm going to also show you that what are the joint conditions, that how a particular column is joined to a beam, and how is the beam joined to floor, and how are all the structural elements joined to wall with all its layers and the joint conditions. Okay, and definitely we are going to provide you the AutoCAD plan of this, and while seeing the video you will notice that how much difficulties as a tutor I am facing while modeling this particular structure, and the tenfold of that you are definitely going to encounter while modeling this structure. But definitely you can lay your questions in the comment section, and I will definitely reach out to all of you and solve your queries. Okay, so welcome back to ptscadexpert and myself, Architect Kumar Kapadia from the city of Surat in Gujarat. And if you think this video was worth, then kindly enroll for the course, which is again going to start from Monday, that is 25th of November. And now, without wasting a single second, let's jump into the interface of Revit. So let's open up a new architectural template while going to new, and I will browse for the folder template file in English Imperial, and we are going to use the default feet inches, that is Imperial system, for this particular exercise. And let's open up the project template. Fine. Now let me insert the AutoCAD file, import CAD, and let me go to desktop and look for the file and colors, all layers, and import unit should be inch, and your AutoCAD file should be in feet inches, and positioning manual center open. So there is the AutoCAD plan loaded in the project environment. And first is that we'll go to VG and import categories and turn this to halftone so we can properly visualize. Fine. Now let's think of a hypothetical situation wherein let's say that we are going to construct or elevate a structure which is a farmhouse or a residential dwelling unit, private or property, which is residing on a slopey terrain on a hilly region on a topographical site, which has typically G+2 structure. That is, the ground floor is the parking with a plinth, and then we have an upper ground floor which is followed by the first floor, and finally the terrace level. Okay, so for this, now there are going to be a lot of assumptions. That is, first is for the topography of the site. That is, we're going to assume that it's going from 0 level up to some specific height. And the next is, as I said earlier, the structural consideration, wherein the beam and column sizes, the footing and everything as far as the structure part is concerned, the basic conventional sizes and everything will be taken. and the exact solution would be given by the structural engineer, and I might be partially correct or I might be completely wrong, but the only intention or the purpose is that how can we incorporate basic structure while working on an architectural model. Fine. So let's first develop this particular topographical site, which has this villa and its own private landscape, that is a children's play area, amphitheater, swimming pool, etc., which is residing on a slopey terrain. So while going to this massing and site, I need to activate this topo surface. Yeah, but for that you need to go to the site plan to develop this particular site, topographical site. So let's go to site plan. Yeah, fine. And again, let's go to VG and import categories and turn this to halftone. And let me just select this and say hide in view by elements. Okay, fine. Now let me go to topo surface and find, let's me place some points. So as soon as you see that I lay points, it start on creating this gradient contoured site. Fine. And I will assume that this is the 0 point, that these two are the 0 point, and the site is having a gradient and going up to let's assume 55 feet. This is just an assumption. The topography is going up to the 55 feet, from 0 to 55 feet. Okay, fine. And let me finish this, and let's just go to 3D and see that now you have your slopey site, which is going from 0 level up to some particular height. Fine. Next is that we need to further manipulate this site, and for that first we need to go to the south elevation and create few levels, the desired levels. And for that, let me just drag this a bit. You can properly visualize. Fine. So first is going to be 0 bottom level, that is the 0 level. Yeah. Next is the road level onto which we will place our structure, that I'm going to consider or assume that should be at somewhere around 30 feet. Okay. Next is let me place a level, and that should be our plinth, that is 3 foot, and 2 plinth level. Yes. Followed by the upper ground floor. Oops. And which has also the first floor above it. And the terrace level. And finally, the last but not least, 9 foot or 9 foot 6 inches, let's say, let's keep it 9 foot 6 inches, the slab top. Fine. Okay. Now let's just align this for proper visual appearance. And then let me just drag it all the way through our site. Okay, fine. So now let's go to site, and now let's start manipulating this particular site. So edit surface, and we right now has only this particular points which are laid at 55 feet. We need to add the intermediate. So 1, 2, 3, 4. I'm just randomly placing the points, and we will gradually step down. So this is going to be, say, 45 feet. Okay, again modify, edit, and place points 2, 3, and 4. Again, this is going to be something like say 40 feet. Again, modify and place points 1 2. Oops, I placed it in the wrong. 1 2 3 4 and 5. This should uh, uh, place points 1 2 3 and 4, and all of this should be 35. We are just placing the points gradually and moving towards 0. So this should be 30. Finally, 1 2 3 and 4. All of this should be 25, and 1 2 3 4 5. All of this should be 15, and fine. Yeah, this will be finish. Let's see the slope. How does it look? Our enter. Fine. So we have a slopey site which is going from 0 0 up to this 55 feet. Okay. So the next step is to divide this particular region. So for that, I need to select this and massing and site and say that subregion. So I'm going to differentiate certain portions of this particular topographical site, and doing this will take a bit of time. So just stay tuned. And let me just finish or complete this shape and have a close boundary. And if I finish this, and yeah, finish. Okay, so now we have differentiated so much portion from this particular site, which we can manipulate differently. For example, I'm just going to select this and lay a new different material to it, and let's call that default, and I'm just going to duplicate that and call that one road material. Copy and appearance. I'm going to open up the asset browser, and by going to appearance library and site work, and yeah, this is the material I want to replace. But after replacing, don't forget to duplicate, or else you will end up messing with the Autodesk Revit material. And by duplicating road material, apply OK, and now you see that we have a distinction. And similarly, for this particular portion, let me go to 3D. And why can't I select this portion? This is essentially earth. Yeah, fine. That the material for that is fine. But still, why can't I select that? Let me say HH and select this. Yeah, fine. And material. Okay. And we are going to give a earth. That is the standard material, and it is the same. Yeah, fine. Okay. And press HR again. Yeah, it was the same. It was the same material. The only thing I need to do is change the styling, but that's not important. Fine. Okay, now what next we are going to do is that if I go to site plan, then we have our structure residing somewhere over here at some intermediate level from 0 to 55. And as you know, I said earlier that I'm going to place that structure at this 30 feet. Okay, so what we are going to do in that case is that we are going to dig or carve this much portion of the site and make it grounded. So what the concept is that basically we are going to apply this particular logic to it. Different civil engineers or different structural engineers follow different methods for this particular task, that is how do we apply the foundation and how do we erect the structure on slopey side. But the basic is that this soil filling, and there are several different approaches, that is you provide the step footing or you provide a rough foundation. This particular thing, you dig out some portion of the soil and fill it on the other side and apply a raft onto it. This is what we are actually going to follow for this particular exercise, wherein we are going to have a raft which will take all our columns and beams and structure. Okay, so this is it. That is, we are going to have a raft slab with all the reinforcement, and we'll have the main beam and then the floor. And in our case, the main beam and the ground beam and the plinth beam are going to be one and the same. So let me show you that how will we do that particular thing. So for that, massing end site, and again sub-region, and no, sorry, not sub-region, but while going to massing end site, I'm going to place a building pad to ground that much portion. I'm just going to draw a rectangle for now, and then pick lines and pick this particular edge, and okay, yeah, it is going to pop up an error because too much of some lines, and this and tr, and let's have a close shape. Delete and tr again. Okay, fine. And now very important that this, we are considering that this particular pad is our raft foundation. So edit type, duplicate, and say raft slab. Okay, and the exact size of it I cannot decide, that structural engineer will decide, but for now I'm just going to keep it for 3 foot, and I'm going to say apply the same material, that is the road material for now, road material. And for the graphics, I'll just change the cut pattern to say concrete. Apply and okay, and fine. So very important that where are you going to place that particular raft. So as I said earlier, while deciding the levels, I said that I'm going to place this particular structure on road level, which is at 33 feet, if you remember, 30 feet, sorry. So this raft is going to be at 30 feet, and I'll just finish it. And if you go to 3D, then you see that that much portion has been grounded and the raft has been created onto which we can lay our structure. Okay, so this is the road and this is the point. So we need to manipulate the surface a bit. Matter. Let's go to site and let's select this and edit boundary. Not edit boundary, but let's edit surface, and let's have a point here. And if you remember that this is the 30 foot, so let's place it at 30 feet, and let's go to 3D again. And now you can see that we have an access from this particular slopey terrain road to the flat road. Okay, so that is how you develop a simple basic site. So moving towards the next segment, now we are going to develop this particular landscape part. Now, but before that, let's add some walls to it, some defining walls, the boundary to this particular structure. So for that, I'm going to go to architecture and wall, and this generate 8-inch wall, I'm going to edit type, and I'm going to duplicate this and call this retaining wall. Retaining wall because it's going to retain the soil and create a fence wall or a boundary which would retain the soil. Okay, edit type, and I'm just going to take it to 15 inches for now, and duplicate this and one retaining wall. Copy and appearance and asset browser, and appearance library, concrete, and I'm going to take this basic simple concrete, and don't forget to duplicate and paste. Retaining wall, yes, and uh, the tiling should be something like 15 feet. Okay, done. Apply. Okay, okay, and retaining wall, fine, and there we go. Okay, so now I want to place this at road level, fine. So let's start placing that wall, and let me just turn this to shaded, so you can know, but shaded we'll not be able to see the AutoCAD plant. So we need to keep it to wireframe and unconnected, not unconnected, but we want to go it to upper ground floor with the top offset of say 3 foot, and wall center line, finish face exterior, and let's construct that retaining wall. Okay, let's see it in 3D. Fine. So the retaining wall has been constructed. Now, what is this concept of retaining wall? That is, let me show you. So, the retaining wall is a wall which is a tapered wall which is actually resting on a raft slab, which takes up all the reinforcement, and it's the reinforcement goes from the slab to that particular retaining wall, and it's complete concrete wall, and it retains the particular soil which is behind it, and the exact cross section, or what do we say, the exact anatomy of that will be decided by again by the structural engineer. But right now I'm just see, this is what the retaining wall, which is having a tapered cross section, which is having a more thickness on the base and less thickness on the top. But right now we have just assumed it to be of 15 inches. But the only purpose of that is that it's resting on the raft and is retaining the soil which is coming from above. Okay, so that is the retaining wall. Fine. Now let's go back to site, and now let's create the other parts and pieces. That is, that's the wall again, and edit type, and this time I'm going to say this to compound wall. Oh, compound wall. Okay, and edit type, and this is going to be the regular 9-inch thick. And for the material, I'm going to duplicate one compound wall. Oops. Control C, Control V, appearance, and I'm going to go to appearance library and masonry and brick, and I'm just going to select this any of the material. Let me just select this brick rustic. Yeah, right. And don't forget to duplicate and give it a same name, compound wall, and tiling should be that's fine, 8 feet by 8 feet. Yeah, okay, apply and okay, and okay, and okay, and let's draw the compound wall, which is from again from road level to upper ground floor, and with the top offset of 3 feet. 1 and 2, and we are going to have a couple of other this particular wall, but with different constraints. That is, base constraint should be road level, and should go to unconnected height of say 5 feet. So that is going to be this landscape portion, this particular. So 1, and press tab and flip the direction, 1 and 2, and likewise here as well. That is, flip the direction, and 1 and 2. Yeah, fine. Now let's go to 3D. Oh, so this was, I forgot to change the constraint for this particular walls. So let's not, doesn't matter. Just select this walls and change its constraint, base constraint to road level and unconnected 5 feet. Yeah, fine. So that will be properly in place. But the material, I guess, let me just change the material because I'm not happy with the material, and let's give it some let me change this to thumbnail and masonry, and just a bit. This is not actually important, whatever material you give, but you just want to make it visually look proper. Yeah, let's just like this. And give it a tiling of the 12 feet. I just want to make it a bit realistic. Apply and okay, yeah, fine. This is okay. Okay, so again, this wall will, sorry, so let's go to site and modify and wall joints and say disallow join and drag this wall up to here and drag this here and drag this here. Okay. Again, yeah, that's fine. Okay. So now let's create the landscape part of this particular site, and this is going to be nothing but we're going to create it at road level, but it is going to be a simple architecture and component and model in place and generic model, and it's going to be a lot of extrusions, so just stay tuned. And generic model, and we're going to say it landscape. Okay, and with that we'll start creating our landscape. So extrusion, and we are going to have a lot of extrusions. The first is the cargo parking, and the same here as well, but I don't think we can have two at a time. Let's just try 2 inch, and yeah, fine, doesn't matter. Extrusion again, we are going to create the swimming pool, the basic, not the exact, but something which would look like a swimming pool. And we just tr and finish this shape and pick lines and pick lines, and yeah, okay. And we are going to deduct the swimming pool part from this, and this should be 0 to, let's say, 2 feet, because the plinth is of 2 feet. Okay, and let's create quickly the steps as well, which goes from 0 to 6 and 2 more from 0 to 12 and from 0 to 18 inch. Nothing but we are just creating the steps to reach up to the swimming pool. So 18 inches, fine. Now we are going to have this small sliver, which is going to be actually the grill from which the tile, which would be, say that from here the swimming pool begins. So we'll just give it a small extrusion of, let's say, 2 feet is the start, and 25 inch, 2 feet 1 feet is the end. Yeah, fine. And lastly, we are going to create this, which is going to be, say, 23 inches and 24 inches, and 2 foot, which is going to be the actual water. Fine. Let's create the other parts. Again, those are going to be the same extrusion. This pathway, and it's going to pop up an error message. I knew it. And that is going to be 0 to 2 inches, and everything is created on the ground level, road level. Let's keep it 3 inches, or let's say 4 inches, a bit high, 2 inch high than this pathway. Okay, and then we have the garden area, of which I'm going to quickly select this periphery. Oops. And I'm going to just select all of this and copy. We are going to use for the other side as well, and pick lines 1 and 2 and 0 to 2 inch. Yeah, that's fine. Okay, and one more extrusion and control V, and yes, move and pick lines 1, 2, and again 0 to 2 inches, fine. And the last is this amphitheater, so let's quickly create that as well. Extrusion and the final one. This is going to be 0 to 6 inches, going to be a step 150 mm, 15 centimeters. Yeah, just ensure that. Okay, so you need to be very specific. Fine. And again, create a couple of extrusions, pick lines 1, 2, 3, and 4, and from 0 to 12 inches, 1 foot. Create extrusion, pick lines 1, 2, 3, and 4. 0 to 18, and one more extrusion, a couple of more, and 0 to 24 inches. Create extrusion, pick lines 1, 2, 3, and this is going to be 0 to 30. Extrusion, pick lines 1, 2, and that is going to be 0 to 36. And finally, the last one, create extrusion, and this is going to be, we need to split lines 1, 2, split line, pick lines and join this and complete the shape. And this is going to be 0 to 36. Oh, sorry, not 36, but 3 foot 6 inches. Yeah, sorry. Okay, and finally, after doing this, just join this 1 and 2. Let's go to 3D. And we have our landscape created. Okay, the only thing is we need to differentiate it by doing it a different material, which I'll do quickly. But before that, I just want to join this geometry. So let me join, and 1 and 2, and 1 and 2. Oh, yeah, and this and this. So we can apply one homogeneous material to that particular thing. Fine. Okay, so now with this, I'm going to just go to manage and create a couple of materials which you can apply to this landscape part. So let me say that this is going to be one ramp material, or yeah, fine. And again, I'm going to duplicate this, or not. Before duplicating, let's first assign the material, and appearance library, concrete, and yeah, I want this particular material for this thing, which would have some sort of a grip, which could serve as material for parking or walkway. One ramp material. Let's change this to 4 foot. Done. Apply. And one more, actually a couple of more. One, what do we call this? Swimming pool tiles. Copy and appearance library. And for this, I'm going to use flooring. Not flooring, ceramics. And yeah, I'm going to say that this should be this, and appearance and duplicate and paste, sample size 5 feet, apply and duplicate. Yeah, that's should be super tiles 1. And by going to appearance library again, and the same but with a different material, and that should also give duplicate. And swimming pool tiles 1, sample size 4 feet. Done. And apply. And grass and mud we don't want, but we want one more duplicate, and that is going to be mud. Appearance library, concrete, not concrete but site work. Yeah, let's have this. And duplicate 1, mud. Tiling is fine, yeah, doesn't matter. And the last one, that is duplicate 1, amphi material, and that is going to be some concrete. Which one? Let's select this and just duplicate that. And 1, amphi, change the styling to 4 foot. Yeah, and after applying all this and doing a lot of work, now what we can do is select this, and this should be the ramp material. Perfect. And this should be the tiles. This should be the another tiles, and this should be water. Apply and OK, and that's fine. And we have our swimming pool created. And I forgot to create one material, so I'm going to apply to this particular pathway. So let me just create it quickly, and let me just duplicate this and call it 1 paver block. Paver blocks. Control C and control go to appearance library, and under appearance library let me go to site work and replace this cobalt cobblestone. Yeah, fine. And just duplicate this and control C and control V, and for the tiling I'm going to change it to 5 feet and apply and OK. Okay, that's fine. Now we are going to quickly proceed ahead with this. Let me look for grass, and yeah, it's there, already there, so we don't need to make it. We want mud, so that material has been created by me. Mud, okay. And finally the empty material, and that should okay, and we have applied that to entire amphitheater. Okay, that's fine. And the only thing left is this particular steps. So let me create one more material for that, and for that I'm going to say default, and duplicate entry steps. I'm just going to give it a simple paint, and that should be something like this. Yeah, okay, and that should be apply and okay, okay, 1 and 2, and that should also be the steps. Where are there? Steps. I forgot to give it a numeric entry steps, and let's have a little bit darker shade for that. Apply, okay, and yeah, that's fine. Okay, so you see that we have created all of our landscape, the retaining wall, and now let's proceed ahead with this particular structure. Let me just finish this with all our landscape created, and now let me go to again to road level and quickly create this before we move on to the actual structure part, the most important one. So this can be actually a generic model, but I want to follow the ideal process, that is stairs, and it's going to be edit type and duplicate entry steps to plinth, and yeah, and the minimum width should be 5 feet. Okay, and just click for material. I'm just going to say that this is going to be the steps, or let's say ramp material. Yeah, right. The same to that, the ramp material. Okay, and apply and okay, and okay, and I wanted to go from road level up to only plinth level. You see that the desired number of risers become 6, and the actual trap depth I want 1 foot, because these are 1 feet. So this is going here to here, and let's just finish. And we have our steps created. I'll delete this railing. I'll select this railing. I'll edit path, and I will just drag it all the way to here and select this and TR and TR. Yeah, fine. And let's make this rectangular head railing to glass panel bottom fill, and you see that your steps has been created with the railing. What only left out is just the plinth, or the floor on which is going to tap, and I don't want the stringers. Uh-oh, sorry. Stringer, yeah, I want this to be none, this to be none as well. Apply and okay, yeah, fine, that's fine. And let me again go to road level and quickly create that. You need to use floor for that, floor architecture, and again edit type and say entry steps to plinth slab, or let's say floor. And this is actually going to be around 3 foot, and we're going to apply the same ramp material and okay and okay, and I'm just going to create that at road level, and the boundary line should be this, and just finish this. So let's see it in 3D. I'm going to apply that. Let's give it a height of sort of 3 foot, and you see that the slab has been created, the floor slab is created. But the ideal situation, in ideal situation, what will happen is that we will have a 6-inch thick wall pardi, RCC pardi, and then the filling onto that particular thing, and the floor will be casted on that. But right now, just for the ease, I just made it entire thick homogeneous box. Okay, so now next is that we want to manipulate this particular wall and we want to have two openings. That is, one is this, another is this. So I just say that edit profile and ask me to go to the elevation. I'll go to south elevation, and while going to south elevation, I will just create two different openings randomly, which is having 8 foot of height. Let's say 8 foot 6 inches the lintel, and yeah, just two openings randomly. And now if I just go to 3D, then you see that our two openings has been created, but this actually needs to be delete and split lines, split lines and TR and TR. Yeah, this okay, perfect. And let's let's properly position these openings. And how can we do that? So again, by going to road level, what you can do is that you can just select this and snap to this particular line, the AutoCAD drawing. Yeah, and we have our openings perfectly in place. Here it is not snapping. Yeah, it is. That's not an issue. Okay, so we are done with this particular part. And so now we are going to enter into the most important segment of this exercise. That is, we are going to construct this structure, this particular residence with the structure part. And so for that, I need to go to road level and start creating the ground beams first, the structural ground beams. Okay. The ground beam plus plinth beams are one and the same because they're having the 3 foot of plinth which is resting on a raft. So let me just, but before that, let me just go to site and not site but 3D, and let me just change the constraint for this AutoCAD plans and change it to road level. Yeah. So now going to road level, yeah, we can see this. And let me turn on, yeah. Okay. So first is structure and beam. We are going to lay beam, but no, before that, let me add structural columns. So columns, and it shows this particular column. So we need to load family and go to English Imperial and structural columns, concrete and concrete rectangular. Yeah, fine. And with this, I'm going to edit type and duplicate this and call this 9-inch cross 18-inch. That is the standard size. And the breadth should be 9-inch and the height should be 1 foot 6 inches. And very importantly, you need to change the constraint when showing the depth and height. So you select height and you say that you want to go up till upper ground floor. Okay, and with that, now let me just place one column, and yeah, let me just go to VG, import categories, and turn this AutoCAD plan to halftone, apply and OK, and turn on the thin lines. Yeah, fine. So WF, yeah, fine, and yeah, fine. Okay. So there is our column placed. So modify, align, and 1 and 2. So let's see that how did we lay the column perfectly? Yeah. So that's fine. And it says that going the base level is road level and resting on the raft and going up to upper ground floor for now. Fine. Now there are two different ways to lay the columns. Let me just show you. If I go to road level and here in architecture there is this option called grid. If I enter this and draw some of the grids, and if I say that columns and structural column and all grids, and if I just select this all grids and say finish, then this columns will be laid on the intersection of that particular grid. we have all this different columns quickly laid very fast. But that is in case of when you have the exact what do we say, the dimension of that when you're using the center line across the walls, and you have the same sizes for the columns which is passing through the center grid. But in our case that will not happen, because you see that the alignment of this particular column at some places is the face line and not the center line, and at some places those columns is changing its orientation along its entire length, so we need to lay it manually. Okay, so let me just quickly do that. So just C O copy, and 1 and 2 and 3, and likewise wherever we have the horizontal columns, I just place it. Oops. It's not snapping. Okay, let's skip that. So this is what happens when, yeah, it's snapping in some case, it's not in some of. So okay, doesn't matter, wherever it is not snapping, yeah, it did. And let me place one here as well, and let me just put space, so that will flip the direction, and let me just move it, and you will have a little bit of error, but doesn't matter, you just click align and position that column properly. Let's align and okay, copy again. Where do we have the vertical columns? Yeah, here. So 1 and 2, and yeah, fine. Let me just place one here, and first let's align this because we're not in position. And for this I will say that align, and yeah, so it will accept that particular direction, and now we can place it and just CO, and wherever we have the slant columns we can just copy and put it, place it there. Okay, and fine. And one more over here. Oh, here there is supposed to be one column. I forgot to place it in AutoCAD plan as well. Oh, sorry. No, here it is there. So it should be there here as well. Yeah, fine. So irrespective of this, let me just keep it somewhere here, and I will just say align and oops, align this face and align this face. Okay, so let's see it in 3D. Wow. So we have our columns placed resting on the plinth. Okay, and we will move very slowly, step by step, and with all that structural columns perfectly laid on that particular raft, which is at road level, now we need to add the beams, that is the ground beams and the plinth beam, one in the same 3 foot of plinth. So let's quickly go to road level, and let me say a beam, and it will show this particular beam by default, but we go to load family and English Imperial and structural framing. Where is it? Yeah, structural framing, concrete and concrete rectangular beams. This is that family, and we need to load that into the project and just edit type and duplicate quickly. 9-inch cross, 18-inch the conventional size, and the breadth is 9-inch, and in this case this beam, the plinth beam and the ground beam are one the same, coming up to 3 foot of height, so we will say that the height of this particular beam will be 3 foot. Okay, and just say and fine. And now with the placement plane should be at road level and the top offset should be at 3 foot, and we have an ability to pick lines, and you can also draw manually. It doesn't matter. Let me just first show you how can you draw manually. So just select the center of that column and lay it. So if you go to 3D, then you see that your beam has been laid. Okay, and before proceeding further, let me first just select all of these columns and change its material to the compound wall, retaining wall material, which has the cut pattern of concrete. And yeah, fine. I just want to look at one homogeneous, and this too also we have the structural material of, say, that particular retaining wall. Yeah, okay. And the another method to quickly lay this structural framing, that beam, is that when in orientation, when you have the beams on particular orientation, then what you need to do is just select beam and pick lines. That will pick the lines and lay that quickly. Then what you just need to do is that modify and align, and just pick this and align it. Oops, it's not. You cannot align it with the AutoCAD plan. I guess you need to align it with the structure. Yeah, fine. And TR and just, yeah, that's perfect. And likewise here, align and this face and this face. TR and join this. TR and join this. Here it's going to create a problem. Yeah, because the space. So again, align and align to this particular face, and yeah. Okay, so we have the peripheral ground beam or plinth beam created. Okay, and in case of this plinth, that will extend further the peripheral beams. So let me just go to road level and drag this all the way to here. Also this true here, and likewise you can just draw beam structure beam, and one beam from here to here and one from here to here. See, my considerations I might be wrong at some places, but just consider I'm not a civil engineer, so I might be wrong at some places. No, and yeah. Oops. And quickly let's drag this as well all the way along its length and join it. Or actually, let's just create let's just create the beam over here as well. Let's extend this and one more over here, from this face to this face. Okay, and finally this two. So one would be here, and I guess we need to align this, or it will not be aligned, so move it manually, disconnect it, yeah, drag it. Structure beam here one. which I need to move to this location. And why is the orientation for this particular beam as? And you see that we have some alignment problem for this particular one beam, which is not exactly snapping to the floor plan. So let's just get rid of it and use an alternate method of creating that particular beam. So beam and just pick lines, and the Y justification, let's say to right. Just click this line. Okay, that's perfect. Now we have the beam created perfectly. And now let's quickly, without wasting the time, create the intermediate beams, and that is supposed to be going from justification again change to center. We're going to join from center to center of column, and perpendiculars in some case. But here we don't have, so again change this to left or right. Yeah. Okay. Perfect. And from here, so this is again a slant line, so let me just pick lines, and the justification, let's change it to right. Okay, and that's perfect. And yeah, it's complete. Okay, so in this case left. So only thing is that we need to join it here. Join it all the way here. Yeah, fine. And also this to this point. Yeah, fine. So now let's go to 3D, and you see that the basic structure has been created. We'll just hide all of this, and this is the way the plinth will be created. Just select this as A, all of this, and let me give it the same homogeneous material of, say, retaining wall. Okay, and fine. Now let's create the slab and the ramp over here. So floor, sorry, not slab, the floor, the plinth floor. So let me again go to, now let's go to, let's just select this plan and take this to plinth level, and we close the bottom level and road level as well. Let me go to plinth level, floor plan, and fine. Again VG, and I'm sorry, but we have to do this every time. So let's quickly create the floor and floor architecture and edit type, and let me duplicate this, and let's say that plinth floor slab, and let's edit type and give it a thickness of ideal 150 mm, that is 6 inch, and give it a material, and this time I'm going to define a material and duplicate and one plinth floor, and copy and asset browser and appearance library, and let me look for something relevant, stone, and yeah, this, I'm going to just define duplicate that, and let's call this plinth floor, and yeah, sample size 5 feet by 5 feet is fine. Apply. Okay, and let me draw the boundary line, which is going to be cover the entire, and just pick lines 1, 2, 3, and split lines, and okay, and there is a floor created. And if we have positioned it properly, then let's go to 3D and see. Oh yeah, perfect. but the material is very dark. So let's change it. Not important, but since I want to lay a perfect material, site work, and stone, yeah, and let's replace this material. Okay, perfect. Then duplicate and paste plinth floor, and let's change the tiling to 5 feet by something. Okay, apply and okay, apply and okay. Yeah, okay, that's perfect, fine. And now, so we have created the plinth floor and the plinth floor slab, and now we need to just join this beams. So let me just hide this wall and modify and join. Let me join all the beams. Oh, sorry. And yeah, okay, two, couple of remaining. And also we will have two more structural framing beams over here. So let me quickly go to and structure beam, and then the same, I'm just going to pick lines that is going to create it on the other side, but just select it and say that I want to be on the right side. And likewise here as well, pick lines 1 and 2, and both of that should be on the right side as well. Okay, that's fine. And the constraints are changed, but that's okay. We are in Revit, so not a problem. Let's change this to 0, and quickly let's select all of that and assign it the same material of, say, um, retaining wall. Yeah, and modify join geometry. Oops, sorry, join. And now let's go to plinth level and quickly create the ramp. So I'll click ramp, and Revit by default comes with two ramp 1 and 2. Much of difference between. The only difference lies in this ramp to length, and the difference is this shape. That is, if you select thick, then it will lay a slab of that preferred thickness, and if you say solid, then it will lay the solid homogeneous substance or material and element, solid element of that. And I would just say that this should be a ramp material already defined. So, and these two parameters are the most important for defining or designing a particular ramp in Revit. That is the maximum inclined length. In our case, in this case, it's 8 feet, and this is the number, the ramp slope derived by dividing this particular maximum length by the amount of height which you want to rise by traveling that length. That is, if we want to rise up to 3 foot by traveling 8 foot unit of length in distance, then you have to divide 8 divided by 3. That is gives the number 2 point, 2.5678 9. This is the number which decides the slope. Okay, so with this, if I just say that a width to be 15 feet, and if I just let me just place it. Oops, sorry, let me just and just select this and move it to the desired location. Okay, and just finish this. Okay, that's fine. But now if you just take a cross section of this, then you will see that, oh, perfect, we have the ramp going from, oh, let's lay that wrong level. Its base level should be road level. So you see that we have the ramp going from 30 feet to 33 feet, and it's covering 3 feet of distance in height versus 8 feet of distance in length, that is inclined length. That was that parameter, that scale factor which I was trying to explain you. Okay, fine. So with this now, if you see that our ground floor is complete with all the ground beams or the plinth beam, one and the same in this case, and the columns. Okay, so now let's quickly start adding walls to it. Okay, that is going to be very important. Let me go to plinth level. So let me click the wall command and let me go to edit type and duplicate this and say one main wall 9-inch. Okay, and go to edit type and quickly add the material to it, and I will just create a new material, default, and let's say that duplicate one main wall 9-inch and copy, and I'm just going to use a simple paint for this. So asset browser and appearance library and paint, wall paint, and I'm just going to use the school white. Okay, and let me just duplicate that as well and give it the same name, one main wall 9-inch, apply and okay. And with base constraint plinth level, I want right now the wall to go up till upper ground floor and with the top offset of 0 for now. And I will just create this walls 1 and 2, and this is again, and for this I will have to create another wall. It's a duplicate and call it 4.5-inch thick and same material, doesn't matter, and just complete the box. I forgot to change the thickness in the assembly, and apply and okay, and just TR and finish. Okay, so with this the walls are laid on the particular plinth level, and let's go to 3D and see. Okay, fine. Now what is important to be noticed is that right now the walls and the columns are overlapped, so we need to join the geometry. So I'll go to modify and I'll join each of these columns with the walls. So what that will do is that it will deduct that much portion of wall and have the column in that place. But now very important thing is to be realized is that, is this the way the construction is laid on site? Is this the way the construction happens on site? Then the answer is yes. The construction exactly happens in this way with this dimensions, that is the column dimension, the wall dimension and everything. But the visual appearance of the same is not like the one right now we are seeing. That is the columns the wall with the columns between. So one way out is that you can just go to this paint and apply the wall material, this wall material to column face, and look at appear one homogeneous surface. Okay, but still you will see these lines. Again, we have the way out of it, that we can go to invisible lines and turn this to invisible lines and have one plain homogeneous surface. Okay, but actually on site what happens is that the construction is done this way, but there is a finished layer of plaster which has been wrapped around this particular structural elements. That is also, if you noticed, and then in case of this flooring, let me just go to south elevation, then we laid this particular flooring. Okay, let me go back to plinth level and take a section. Yeah, okay. So in section, if you just visualize, then this is the way right now it is appearing, and the plinth floor slab, let me just change its graphics and cut pattern. Cut pattern is concrete, then why is it not showing? Because that floor is cutting, I guess. Yeah, then it should show the cut pattern of that. Oh, sorry. Yeah, so this is the way it has been it's been displayed, or which shows that there is a raft and which is holding this plinth or ground beam, and that the slab is casted at this particular floor level, that is the plinth level, the floor is casted. But this is the unfinished level. So everything what you have seen up till now are the elements in its unfinished state. That is, the columns, the beams, the floor, and everything are the unfinished state with exact dimensions of the structural dimension, exact structural dimension, how it will be casted and built on site. But there is a layer of finish level on everything, that is even on beams, and not actually the ground beams, because they are not going to be visible, but at least on floors and the walls, and also the beams which will come on the upper side, and the columns which are going to be exposed, this particular columns which are going to stay exposed, we will have a finished layer of plaster onto that, and after applying that plaster layer, that should look one homogeneous material and one homogeneous surface. So I will just delete this wall, and I'll show you that Revit has an ability to do that as well. And how can we do that? And let me again go to this and apply the same retaining wall material to these two columns, since we changed it, and this column as well. Okay, fine. So now let's go to first section, and let's do that for this particular slab, that is, which has been casted on at the plinth level. Okay, and before that I just want to show you that what is exactly the anatomy of a floor which is going to get the floor slab which is going to get casted on the ground floor or the plinth level, which is actually a 150 mm thick flooring which is resting on this 150 mm RCC slab. So in total it will round up to something around 300 mm. And if you just go to the detail of that, then it says that on this RCC slab we have this 100 mm thick BBC brick beds for waterproofing, then a chemical is also applied to it, then the sand beading 20 mm, then 12 mm mortar, and then finally the finishing material. So this is the anatomy of the flooring on the ground floor or the plinth floor, which on the first floor, again on the first floor, becomes 75 mm thick flooring. Okay, so we are just going to create this flooring in Revit. So how can we do that? So let me just go to floor and go to edit type, and Revit has an ability, but since we are going to deal with this micro units, so that is 12 mm and 20 mm and 40 mm, I'm just going to change the units for conveniency to, yeah, it's already millimeters. Okay, so let me just select this plinth floor slab and go to edit assembly, and I'm going to add a couple of layers to it, of which this will be say 40 and then which is the brick beds, sorry, not 40 4 inch, that is 100 brick beds. Then we have the 20 of sand beading, and the 12 of mortar, and finally the finishing material of 19 So then you see that's round up to 303, around 300 flooring. And now let's quickly create materials for that, which are not actually going to have anything in appearance, but we are going to deal with this graphics since we want to see that particular thing in the cut pattern. So let me just create one. There's going to be brick beds, then duplicate that as well, duplicate one, that is going to be sand bedding, and then duplicate that again, one, that's going to be mortar, and finally the tile, the finishing material is already defined. If you remember, we have already defined that particular material, that is this where do we have that, paver blocks, yeah, that is going to be the finishing material. Okay, so for brick beds I'm going to go to this cut pattern, and we are going to look for something relevant, but we don't have brick beds here. So in this case what we need to do is that define a new material, let's call it brick beds, and for that go to custom, browse for the pad file, AutoCAD pad file, since we are going to use AutoCAD hash pattern, and then look for bricks and brick, and this bricks, we are going to use this particular bricks, and the import units, let me just change it to 0.05, only 0.01 for now. Okay, and then for the mortar I'm just going to use the existing gypsum plaster, and for the sand bedding, where is it, sand bedding, I'm going to use this particular sand dense, yeah, okay, fine. And now I'm going to apply those materials to this, wherein the first will be the brick beds, 100 then is the sand beading, 20 and then we have the mortar. Okay, and finally the finishing material, that is the same plinth floor, and we are going to apply the same material so that we can see it. But for that, the plinth floor, the cut pattern should now be none. Okay, and apply and okay. And for this particular structure I'm going to for the plinth floor I'm just going to use any of the existing concrete material, that is, let's just, which has the yeah, this custom. Okay, fine. And now just by clicking OK, now you just see, then you see the cross section of it is now showing that we have a slab, then we have this layers resting on that particular slab. Okay, apply and OK, and you see that I just need to go to UN, and let me just change that back to feet and fractional inches. Okay, and I'm going to turn it to 1.8. But for this particular material I again need to go to and change the import units so you can visualize properly the brick beds, and just edit it and change this to 0.1, or let's say 0.5. Okay, yeah. So you see that now we have the 150 RCC slab on which we have the finishing various layers of flooring. Okay, and just click OK, apply and OK, and you can see that. And we are not going to worry about its appearance in this particular floor plan, because we can definitely give it by making a call out of it and making an enlarged detail, which I'll show you in the later part of the video. But this is exactly how the floor is casted. But again, there is a problem, because you see that this is the level, this is the floor level. Let me just change this to, so this is the plinth level and the slab is here, so much down. Okay, the finishing that we added, the finishing layers, 6-inch finishing layers are added onto that slab, but it is still below this plinth level. So what could be done in this case? So now we have to trick Revit. Since we want this particular slab to merge with this, since at intermediate level somewhere over here we are going to have a beam. Okay, actually let's be specific, talk about this particular thing, this particular wall. And yeah, so this particular finished layer which we have added to flooring should go up, and this RCC, this unfinished level, should come at this plinth level. Okay, so how can we do that? We'll just click and we have this inbuilt parameter height offset. I'm just going to raise it by 6 inches, and you see that how beautiful it is. And this is the exact anatomy how the floor, the slab is casted, and its connection with the beam and the column which is resting on the footing, and we have the finish floor level. And we just go to 3D, then you will have this extra 6 mm added. So again, you need to manipulate the slope for this, which I'm not going to waste much time on that, but right now just randomly such that it okay, 2, or let's say 2.2 and 2.3. Yeah, so there's roughly this particular ramp is going up to that particular height. Okay, so now let's after this flooring, now let's switch on for the wall part. Okay, and this is plinth level plan, and I need to go to plinth level. So where are the AutoCAD drawings? Why can't I see it? Oh, okay, we need to change it to wireframe. And now let's start creating the exact wall. After flooring, we need to create the walls. Okay, so architecture and wall, and the same thing we did for flooring, while now we need to manipulate the wall assembly in the same way. And let me just insert and 2 layers, and this, since it is on the interior side, it is supposed to be that finish 2, and something which is above the core boundary, that is supposed to be finish 1, and this I'm going to call half, and this I'm going to call half again. Okay, fine. And we are not going to apply any material to it, and that is just going to be the plaster. And if I just see now, then you see that 2 layers are there added. Okay, so okay, apply and okay. Now it is very important that how do you particularly essentially lay this particular wall after defining 2 external and internal plaster layer. How will you lay this particular wall? So now you have to play with this location line. Okay, so with the finished face exterior selected, if I just draw this, then you see that let me just change this to fine, and you see that the plaster layer is added, but it's added on this particular face, and again we'll have the same problem. So I'm just going to delete this and say wall. So I'm going to say wall, and the location line should not be the finished with exterior, but it should be the uh, wall center line, or let me say core center line, or even it will work even if you select this core face exterior, and you see that now the plaster layer is being added, but it's wrapping the existing structure. So I'm going to just draw this particular wall. It will come only up till here. I'm going to start another wall from here, and likewise go up till here and press tab, and we need to define a couple of 9-inch more walls. So let's quickly add that. And you see that now the walls are wrapping with the structure part, that is the columns. Okay, and we need to go to walls, and for the 4 and 5-inch thick, 4.5 thing, we need to again insert two layers, plaster layers, and apply and OK, and then add that 2.5 and the core face exterior. With that selected, I'll just press tab, and now you see that and oops, I'll just stop it here, and TR, I'm just going to join that. Okay, and we have here as well. Okay, so now what next is that we want to have that cross hatch for this particular wall, just like we have for that concrete hatch for that particular column. You can see that we don't have any hatch for column, we don't have any hatch for wall. That is because we have not defined that yet while defining the material. So let me just go to edit type, and for the main wall material, for the appearance, that is fine. For the graphics, I'm going to say that the cut pattern should be this oblique lines. You can create your own and load the AutoCAD pad file, and you can select your hatch pattern from that, but I'm just going to use this existing for now. Okay, and with this we are also going to create one more layer, but that will go by going to that specific segment. That is, we also want this wall to appear complete white. Right now you see that two different layers, half-inch plaster layer. Let me just show you. Apply and OK, and see, this is appearing perfectly. But if you go to 3D, then you see that the wall is grayed out. I mean, it's appearing to be some gray. So in order to appear at complete one white, that's in the material which we apply to the core structure, we need to apply the same material to that, to the external layers as well. But the only difference will be that it will not have the cut pattern. So let me just select this and go to edit type, and for this I'm going to say that duplicate, and one I'm going to call this external paint, or let me say external duplicate, and I'm going to call this external layer. And everything will be same for this, but the only thing that we will not have the foreground pattern for this, the cut pattern for this. Okay, and apply and OK, and I'm going to use that same for this as well. And if we are doing, then let's do it for that 4-inch wall as well, 4.5-inch wall as well, external layer, and the same external layer copy and paste here as well. Okay, and let's go to 9-inch wall and okay. And now you see that it's appearing perfect, one homogeneous surface, which that with that structural part column. The only thing that we need to go to plinth floor plan and join all of this, modify and join all the columns with the wall. So now you see that this layer gets differentiated. Join and yeah. Okay. So this is how you join, and we don't have a column here. Oh, might be I forgot to add a column here. Just do that. But let me just complete this process first. Join and perfect, and this okay. Okay, and we have one more column here to flush with this wall. Yeah, fine. And let me just have a check. Here we have a column. Okay, but we haven't placed it. Forgot to. So let's just CEO copy and copy this point and copy it to this particular. Well, let's just randomly place it somewhere, and we will use align tool since we don't end up adding it somewhere. And this face to this face. Okay, and just join geometry, and yeah. Okay, so now if you go to 3D, then you see that we have a structure, that is the structural columns perfectly incorporated in part of that masonry wall, and that is what I wanted to look at as a one homogeneous surface. And for this, this is appearing because, and this not is wrapping because we don't have a wall here. But in this certain situations, what you can just do is that use a trick and get your thing done. Okay, fine. Okay, so now the next thing is that we need to add structural framings, that is the beams, on the upper ground floor, which would connect this entire structure, this columns, and also along the walls. Okay, just as we did for this particular ground floor, we added the ground beam, plinth beam. We need to add beams for this particular level, that is the upper ground floor. So let me just go to the ceiling plan of plinth level, and while going to structure, I'm going to say beam, and there are a couple of methods you can do this. You can actually go to the floor plan of this upper ground floor and lay that beam just like we did for the ground and plinth beam. While going to the road level, we directly laid that beam onto that particular level. But I want to follow this alternate method wherein we are going to lay this on the ceiling plan of plinth level, and just go to edit type. And this is that particular beam which we added to the road level, that is the plinth beam, having a height of 3 feet. Let's just rename that so we can have a clear distinction. And then we are going to duplicate that and call this 9-inch cross 18-inch. And for the height, I'm going to enter 18-inch and just click OK. And now very important that even though we are working on the ceiling plan of plinth level, I want the placement plane not to be plinth level but the upper ground floor. Okay, and the by justification right, z justification top, z upside value 0, everything is fine. And now let me just connect this to this, and yeah, you see that our beam has been laid, but it's not laid properly. That is because we don't have anything to reference. So in this case, what we need to do is just go to 3D and take this AutoCAD plan and change its base level to say upper ground floor. And now again going to plinth level, you see that we have something to reference. Let's quickly go to VG and first let's half tone it so we can have a proper visual appearance, and let's just delete this for now. And again beam, and for the Y justification I'm going to call it center, and then I'm going to add from center to center, and yeah, you see it's perfectly laid. But it is going to create problem in this case, so not an issue. What we can do is we can just pick lines, and that will pick that particular, but we need to have some trial and error in this case. Let me select left, the Y justification, and just place it. Oh no, Y is not perfect, so let's try right, and yeah, okay. And likewise this as well. Oh, it's perfect. And you see that how quickly we can lay the structural framing with this help of this commands. For this we need to see that left, and again this is going to be left and left, and yeah. Oh, so in this case we change it, or let's just orient this, yeah, sorry. Okay, so we need to pick this line but change the orientation, and likewise, okay, and this and this, again, and this, this should be right as well, and TR, and join this with this. Okay, and you see that we have perfectly laid all the beams. Only one last, I need to connect this with this, and perfect. And let's go to 3D, and you see that we have created the structural framing on the upper ground floor. Okay, the slab, upper ground floor slab, sorry, not floor but the slab bottom. So again, now how to deal with this particular problem, that is, you can see that here you can see the finished surface, but here you can see the structure. And most importantly, yes, don't forget to join this geometries, and we can do that by going to print level plan, and let me uh, quickly join this wireframe. I know we cannot still see it, but okay, let's go to 3D, and yeah, so this is joined. So likewise we need to join all the structural framings for the wall. So just select that wall and click this, yeah, okay, and just okay, and that's perfect, yeah. And oh, we forgot to add the structural framing, the beams onto this particular wall. Just do that quickly, don't worry. Let me just first join this, and yeah, so now these walls are joined to that particular structural framing, and we need to add one structural framing, one beam here. So let me go to print level and quickly let me use beam and just draw one beam from here to here. And oh, again, it's just justification is let's keep it center. No, left. Oh no, then right. Oh yeah, that was proper earlier. And let me join this to this, and let's see it in 3D. And yeah, it's perfect. So let's just modify and join, and let's join that wall. Yeah, okay, it's joined. Structures also need to join the, yeah, they are joined actually. and this. Perfect. And yeah, so with this, now one last changes left is that you can see the naked structure right now, which we want to give an external layer of plaster, but we don't have any wall here. But we can trick Revit by following this method, that we can just go to the plinth level floor plan and click wall and have a dummy wall which would go from base offset, let's say 8 foot 6 inches, up to the up to the top constraint, the upper ground floor. And again, you cannot see anything. So let's go to this plinth level. And yeah, the placement plane is the placement plane should be the plinth level. And sorry, the base constraint should be the plinth level, and base offset should be 9, and top constraint should be upper ground floor. Yeah, fine. And just quickly draw the walls along that structural framing. Let me draw one here, architecture and wall, and from here to from this point to this particular point. Oh, sorry. From this point to this point, and from this point to just flip the direction by pressing space, and all the way to here, this point. Highlight the wall. Yeah, that's not an issue. And again from here to here, and likewise here, and it's perfect. Just create this dummy walls, and okay, and I need this slant one. Is that perpendicular? No, I guess we made a mistake. So again, wall, and just pick lines, and we can just manually align it. Align and this way. Oops, sorry. Align and this way. Oh. And likewise this from center, no, not center, but the location line should be, let's select the wall center line, and yeah, we need to keep flipping between the locations line as far as drafting in Revit is concerned. So again, you see that it's not snapping here, but let me just, okay, and here, did we draw? No, we didn't. So let me just draw it here as well. Okay, and this and this as well, and just make it join, and this to here. Oh, sorry. Okay, that's perfect. And now just go to 3D, and you see that entire structure has been wrapped with that plaster layer of external plaster layer of wall. And now quickly just keep on join geometries, and this is how we trick Revit look at the perfect visual appearance. You see that it's perfect now. Last one. And if you can see properly, then we also need to wrap these two beams, this beam and this beam as well. So let me quickly do that. I'm going to plinth level and plinth level reflected ceiling plan and go to architecture and wall and draw that particular wall with that constraint, top constraint, and this unconnected height, base constraint plinth level and base offset 8 foot 6 inches. So let me draw that. And the finished face wall center line and 1 and 2, and likewise here 1 and 2 as well. And let's see it in 3D. Okay, and let's just modify and join geometries. Perfect. And this with this, and also I guess is there anything left to join? So here we again forgot to draw the wall. No, but the wall is there, but it's not wrapping. Might be some issue of laying that particular beam, because here it's wrapping and here it's not. So let's just delete that, and we deleted the framing, structural framing, but I want to delete this wall. And yeah, let's go again back to this and architecture wall, and with that same constraint, this is that particular, which is that junction. Let me just one, two, and one, yeah, the third one. So this particular thing, and with that selected, this join and 3D, and okay, modify and join. Yeah, perfect, absolutely perfect, no issues. The only thing left is for this particular floor is now that we also need the coverings for this columns, this exposed columns, just like we did for beam. We also need to do it for columns. Okay, and I guess this particular, yeah, this is fine. So what to be done in that case is just go to plinth level, and wherever you have the exposed columns, just change this to plinth level and base offset to 0, and top constraint to fine, and the base and the top offset to say, or let's say that we wanted the unconnected height of beam depth, so that could be 8 feet 6 inches. Yeah, fine. And let's quickly create those walls, and 1 and 2, and likewise for all the columns. And the last one, and let me, without wasting time, if we have done with everything, yeah, just modify and join geometries, and this, all of this, and after joining this, if you just see it in 3D, then you see that we have one homogeneous surface and we don't have any exposed structure. But in certain cases, the Revit couldn't find the wall, the the perpendicular segment, so that's why it's leaving. But we cannot do anything for that. So the only thing that approach is that we need to trick Revit again by going to this paint and apply that same wall paint onto that layer. Yeah, so you can see that there is an external layer which is wrapping, but it's not showing that. So we are technically correct while doing this. But the only thing that we have used an alternate method for that. This particular face. Okay. Okay. Fine. And likewise for all the columns, it's going to take a bit of time, but okay. So with this, now you can visualize this, that we have our structure incorporated, but still you cannot see the structure, and it's embedded and it's joined with the masonry. And if you go to the floor plan, then one last thing, if you go to the section, then one last thing is left, is that you need to join this walls with the floor as well. Yeah, okay. So we have a slab and we have the finished flooring with all that aggregates and the layers we added, and the external layer of plaster is wrapped around the wall, but it's not uh, getting embedded in this flooring. So it's perfect anatomy now, that how our structural members interact with the architectural members, that is the beam, it's to floor, it's to column, it's to wall joints. Okay, and let me just go to this plinth level and take one horizontal section. If you just go to this particular section, then you will see that just turn on the, and what you need to do is that turn it to fine level and just join geometry and achieve that same joint. That is, the floor is to wall, is to beam, is to column, and everything perfect. Okay, so this is just a one-time work, and you can schedule and quantify this very perfectly with the perfect appearance, and also it is technically showing the perfect thing, that how it is joined. Okay, now let's quickly create the slab which is going to rest the upper ground floor slab, so you can understand it properly. Right now there's no slab, so let me just close this all and let me go to upper ground floor. And first let's just go to lecture reference plane and draw a reference plane and modify and align this particular reference plane with this edge, and have that particular floor plan perfectly laid onto this before creating. And now going to architecture, and now we create floor architecture, and we are going to edit this same, lay the same plinth floor slab. We will duplicate that, call it upper ground floor slab, and just okay. And you see that we have this ugly fractions. That is one of the reason we switched the units to from imperial to metric and mm In we laid all these layers. That's okay, not to worry about it. And just click the boundary line, and you can also pick the walls. And okay, just switch this TR and fine. And I think we don't have a slab here, so just finish this and pick these lines. These are all the thin lines. Yeah. So pick lines and pick this TR, TR, fine. Just TR and get rid of this line. And also we don't have slab over here, but we do have here. That is actually going to be the flower bed, so slab will not come at this particular level. So what we just need to do is that join this with this and follow this and TR and fine. 1, 2, 3, 4, 5. So just finish the editing part, and with that, we also need here as well. Split lines, and yeah, okay, and done. Line cannot intersect. So yeah, finish. Yeah, don't attach. And let's just go to 3D, and you see that our floor has been laid. But if you very closely observe this particular slab, then you will notice that on one particular floor, on the upper ground floor, wherein we have different segregated areas, wherein if I just take you to this AutoCAD plan, then we have a wash area over here, and this is entire garden, and we have a hard landscape over here and soft landscape over here, and the most important, this entire living room is having a drop slab. The water body is there, so we need to provide a drop slab just like we provide in washrooms for the waterproofing purpose. So you cannot lay this particular slab like this. And one more mistake which I made is that this particular beams which you see, it's okay that we provided the tie beam onto this particular plinth level or ground level or road level or plinth level, you say, but this is not this beam will not come at this particular floor, and actually that will come at first floor, because if you see the plan of this particular upper ground floor, then we have a wall which is going coming like this, and this has a little bit of depression and it's going straight like this, so we'll not have these two beams for this particular floor. Okay, so let's just do that, and I press HH, and I will get rid of this particular floor that we created, and I'll just completely delete it and press HH again, and fine. For the first thing is that we need to properly lay the beams, the connecting beams, tie beams, which are going to not part for this particular floor level. So we're going to upper ground floor. I will, sorry, not upper ground floor, but the ceiling plan of plinth level. And let me very quickly get rid of this connecting tie beams, and also just watch here when I select. Right now we have selected the wall, and let's just drag the wall all the way till here. Yeah, and join elements, and the structural framing as well. Yeah, and join elements. And this too, I guess we don't need at this level, so just delete it. And fine, now we need some reference. We want to bring this particular, because we already have this wall and the column, I mean the wall which is covering the which is acting as the finishing layer for the beam, and the column at that particular layer level. So you can see that, just press HH, and you can see that we have the wall acting as a finishing layer, and the concrete beam and column, everything in place. What we need to do is just connect this area and get rid of this. Okay, so let me go to planes level again and just HR until we can see the AutoCAD plan, and select this wall first. You see that I'll click and this wall is selected, and I'll just drag it up to this point. Yeah, and join elements. And it did change its, and very smartly you have to work. Yeah, and join elements. And all now this beam, that is the structural framing, and that up till here, and perfect. Okay, no, the alignment has been lost. So again, one more time, and snap to the exact perpendicular, or if not perpendicular, then this line. No, and you have to be very careful while you lay this, and drag this point here. Yeah, that's fine. Okay, and now we need to add this particular structural framing, that is the beam between these two columns, and also provide that the external plaster layer of wall. So I will say that beam, and while on the plinth level I will just say that actually let's add that at upper ground floor like we did for the other beams, and the placement plane is upper ground floor. And let me just check that is the placement plane for this beams. Just tab and select that column, and what is the placement plane? Yeah, that's upper ground floor. So let me go to upper ground floor and add beam, and with that placement plane I will just draw one beam like this, but you'll not be able to see it here, but you'll see it, and just change this to say right. Okay, but we also need the, now let's add the wall that would act as the finishing layer, and upper ground floor, and this should be at plinth level and unconnected 8.6. Yeah, that's fine. And with the core face exterior, I'm just going to select this and join this. Let's see it in 3D. No, base constraint plinth level. Let me say that. Okay, sorry, I got it. I need to change the top constraint to upper ground floor and base offset to say 8 feet 6 inches, and that will make it in place. Yeah, perfect. And then just modify and join the wall with that column, flush it. Only thing is that we need to TR and join this to this. Okay, that's perfect, absolutely perfect. And now we don't have any problem. Again, this layer, this layer is, let me take it all the way to here. And now if I 3, yeah, it's done. Okay, so let's move further. So this is a bit of a tedious job, but you know that if we want to have everything appear perfectly and look perfectly in such a way that we can schedule and quantify it properly, then we have to do it. So now next is that, let me go to this floor plan of this upper ground floor, and let me lay the slab architecture and floor architecture. And for now I'm going to edit this upper ground floor slab and delete all this, and we can add it later, but right now I just want to make sure that we lay the RCC slab properly in place. So for that I want to draw a rectangle first, and then I will just get rid of this two lines, and then I will pick lines and make sure that I deduct so much portion, which is the sunken slab and the water body, from this particular boundary. And to do that we need to snap to the AutoCAD lines. Okay, and let's finish it properly, and this should join with this, and this should join with this. Yeah, and let me select this particular line which would actually connect with this. I need to select this front line as well, TR and yeah, finally. Okay, so we are going to move step by step and create different slabs at different level. So just follow, and this should be TR and okay, and one more. Yes, and now let's just finish, and don't attach, and fine, let's go to 3D. Okay, so now what next is that we need to have the drop slab to take that water body, and which will be flushed at this particular beam bottom. Okay, so let me quickly go to upper ground floor, and again by going to floor architecture I'm going to lay the same slab. I'm going to pick lines and draw that periphery, which would be the sunk slab, to have that water body. And connect this with this, and okay. And I would say that I want the height offset of say minus 18 inches, or let's say minus 12 inches, because 6 inch is the thickness of the slab. Okay, and let's just see. Lines cannot intersect each other. Yeah, sorry. And let's don't attach, and fine, let's go to 3D, and you see that we have our sunken slab, okay, created. So what next we just need to do is that we if you remember that we deleted those tie beams which were not actual part of this floor, but we will have the tie beams over here. Okay, so let's the exact solution will be decided by the structural engineer. We can just tentatively give the locations, and we can give the tentative design of the structure part. Okay, so let me go to upper ground floor, and let's go to structure and beam, and let me create this beams 1 and 2, and likewise here. And why is it showing me so much of errors? Yeah, it's laid perfect. It's laid perfect. Then why it is showing the popping the error message? Doesn't matter. We are going properly. Beam and over here and here. A lot of warnings. Connected with this. Okay. Let's go to 3D. Yeah. Perfect. So we have the sunken slab created, which would act as a water body, and where the chemical treatment will be done, the brick beds will be laid, and everything will be done, and which will have the water, and onto that we will have the floating living room. Okay, so let's now proceed ahead. And before providing the finished flooring to this particular RCC slab, I want to actually lay the other parts of this upper ground floor also, the slabs which are going to be part of this upper ground floor also. Okay, so let's do that quickly. So let me go to upper ground floor, and let's say that we are going to have architecture and floor architecture, and this is going to be duplicate, and I'm going to say it that wash area. Okay, which I'm going to have a boundary from here to here. Okay, and I'm going to have it at an offset of, let's say, 6 inch, because we are anyways going to provide a finishing floor material of at least 6 inch on this particular slab, living room slab. So this is 6 inches proper. Let's just finish on attach, and also this floor and architectural, and again duplicate, and let's say call this hardscape floor. And okay, and for this we'll just give a drop of -3 inch, and let me just create that. Create it here, and here the veranda, that will also follow the same alignment. Pick lines and join this. Okay, and let's just finish on attach, and finally the garden area. So floor and floor architecture, and edit duplicate, and let's say garden area. And okay, from that too we are going to have a depression of 6 inch. You have some waterproofing over there also, and that should be from here to here, and we need to now manually pick lines. And TR, yeah, fine, and select this.
actually, let's add split lines and connect this with this, connect this with this, and join this with this with this, and here as well. We need to trim this as well, and let's finish it. Yeah, and finish. Finish. Yeah, don't attach, and we could actually take this as a hardscape, edit boundary, and this much portion to be the hardscape. So let's delete and pick this line and TR and delete and pick lines, finish, and join this with this. Okay. Yeah, don't attach. Okay, so now let's see in 3D that what did we create. Fine. So we have different floorings at different levels, and this is the way the floor will be casted, which will be having different levels at this upper ground floor because of the purpose it serves. That is, some part is hardscape and some is, and finally this balcony, which could be actually part of this hardscape floor. So edit boundary and pick lines, and 1, 2, 3, and 4. Just finish, TR and join lines and don't attach. Okay. And before we proceed further, let me just have a closer look to this. If I might have gone wrong somewhere, and yeah, see, this is the portion, and we actually reduced the wall and the beam up to here, but it was supposed to be reduced till here, and here we will have the straight wall and the straight beam. So let's just again hide this particular thing, and let's go to length level floor plan, ceiling plan, and let me just quickly take that till here and this till here as well. Okay, fine. And if it is done correctly, yeah, it does, then let's create the beam here, and that will be enough to make it perfect. So let's go to, yeah, okay, so structure and beam, and link beam and upper plane, yeah, fine, and just draw one beam, connect. Okay, and with that, this at plinth level and base offset, let's say 8 foot 6 inch. And try to connect the finish face exterior knot to wall center line. Okay. Yeah. Just connect this structural member to this structural member, and if it is not, then just drag it up to here Let's see it in 3D what's happening. Here. So, okay, that's perfect. And just modify and join. Is this creating a problem? Join. Yeah. Okay. So now we don't have any problem, and it's perfect. And if I just press HR, then hide this AutoCAD plan, and also we need to edit this floor and join it here. And you see that while working in Revit you need to be very precise and very careful, otherwise you'll end up in errors. And I'm just going to select this and this should join here, and likewise this should join here. Okay, let's just finish and don't attach, and let me see if it is okay, no problem. Yeah, it is having a depression of 3-inch flooring difference. And let's quickly add the remaining tie beams. This kitchen area and this balcony, and this will have some tie beams. So let me go to plinth level and just HH that AutoCAD plan. Okay, fine. And a structure and beam, and should be laid at upper ground floor, no problem. And just flip the direction. Okay, and that should go inside. And likewise here also you have one. And likewise 2 here. Perfect. But this will flip, it will take right. Yeah. And this is perfect, no issues. You can just AutoCAD plan, yeah. So this will have the another direction. Sorry, not center, but and with this you also need to lay walls for that particular. Before that, let me add this beams, and this particular slab is how much? This is 3-inch down and this is 6-inch down. So let's have a beam which could 1, 2, and have a depression or have a height of 3-inch less than this. So edit type and duplicate. This should be 15-inch, and the height should go to 15-inch as well. And okay. And let's see it in 3D. Yeah, okay, that's fine. So, but that's not laid properly. No, it is, but because of the level difference, you can seem like that. But this is okay, perfect, and no issues with this. And also this. Also this has some depression of 3-inch. So again, both of these beams will be the one that we just created, 9 cross 15. And let that go down Z offset value of minus 3-inch to flush. -3 inch. Okay, that's perfect. And likewise, this slab is also 6 inch down, so both of these beams will go duplicate only up to 12 inch. See, as far as the structure is concerned, my considerations might be wrong, but you can definitely consult a civil engineer and get it correct. And I'm just taking assumptions for the sizes and the way it is, because my purpose is to show you that how that thing is joined in one another. Okay, and it's perfect, and yeah, everything is fine so far. So one last thing left is that we need to add the layer of external plaster layer to this newly added beams. Okay, so let's quickly do that. I'm going to the ceiling plan of plinth level and click wall, and with plinth level base offset 8.6, top offset this one, connected height 18 inch, and let me just select the wall center line, and that will probably, let's pick lines. Oh no, sorry. So let it be the wall center line. Oh yeah, perfect. And likewise here, and likewise for all this. And perfect. Yes, let's go to 3D and let's join the geometry at least for the wall and the beam, and connect those beams, TR, and yeah, those are the ones. So I think we need to, yeah, okay. This I guess is not still joined. Oh. Okay, now it is joined. This is joined, but this is not yet. Okay, so now everything is joined, and likewise here, let me just have it an offset or base offset of 8 foot 3 inch. Oh, sorry. With this particular slab, where is that beam placed actually? HH. Look at -3. Okay, so let's this be 8 foot 6 inches and this to be unconnected 1 foot 3 inch. Yeah, okay. This to be also this wall unconnected, and 1 foot 3 inch. Okay, and let's quickly join the geometries. That is joined, and the main wall with the not floor, but yeah, this is joined. Let's hide the floor for now. Yeah, so this is joined, but this is not yet. Okay, fine. HR. Here. And let me just hide this floor to have a check category. And if I just closely have a look, then we have added the finishing material to all beams except for this beam and this wash area. These two are still left, so let's quickly do that. And into architecture and wall, and plinth level 8 foot 6 inch offset, and that slab is 6 inch down, so it will have an unconnected height. Or let's right now just take it to upper ground floor, then we will change the constraint once it's made. And core center line, and yeah, 1 and 2, and likewise for all of this, 1 and 2 and 3. Okay, 1, 2 and 3. And let's see it in 3D now. HH, and this has the drop of -6 inch, so this should also have the top offset value of -6 inch. Yeah, so now you can see that it's perfect. And likewise this wall and top offset of -6 inch, and we need to join it, and we have joined this as well. And yeah, this doesn't have any offset, so let's quickly join. And yeah, so now if you see, then we are done with all the structural framings, the columns and wall joints for the upper ground floor, and it's perfectly visually appearing. And this ground beam and pin beam don't need the external layer of external finish layer, because anyways they are going to be hidden. Okay, so now just let's HR, hide this AutoCAD plan again, and the next step is to perfectly pursue this floor and join them to all the structural elements as well as wall. So I'll just press HH, and before proceeding further, let me just check whether I have differently. Yeah, this is the wash area, this is the hardscape, this is the garden, so we can just apply a different material. And this is the upper ground floor, but that should actually be duplicated as well, and let's call it upper ground floors water body. So just we can apply a different finishing material to that. Okay, and now first, without wasting time, before applying the finishing material, finishing flooring material to all this floors, let's first quickly join these floors to the structural framing and the wall and everything. Okay, so this will just take a bit of time, so stay tuned and just follow. Okay, manage, join. So you will notice that there are certain situations when we could not join the floor with the structural elements or the wall. That is because while drafting this 3D elements, we might have snapped to some wrong plane or wrong line, and the only way out to fix this is none other than you have to delete those elements and draft it again properly. Okay, so quickly without wasting time, let me do that. So let me just hide this floor for now, and let me just delete this one and this framing and also the structural framing. Just watch here that whenever I select it, we are selecting the concrete rectangular beam, and just delete it. Okay, fine. And also let's delete this main wall. Okay, and let's do it other quickly again. And while going to the ceiling plan of plinth level, first is that I'm going to say structure and beam, and this time I'm not going to make any mistake, and let me press HR and make visible the AutoCAD plan so that we can have a reference of what we are going to snap to, and just select beam and concrete rectangular beam and justification center. Yeah, that's fine. And just make sure that you snap to the perfect line, otherwise you won't. Let this justification be left for now, and let me just pick lines. Okay, so this beam is created. Now let me just hide the AutoCAD plan and TR and hover until and press tab until you find this concrete rectangular beam. Watch here, and press TR and press tab until you find this concrete rectangular beam, and just join it with this. Okay, and very important that what line do you snap to. See, this orientation should not be, this alignment should not be lost, and should be very perfectly joined. And now if I go to 3D, then HR, hide the AutoCAD plan, HR, and just go to modify, join, and yes, finally. So again join, and this column as well, and join this face as well, and you see now it is perfectly joining. And the last, and yeah, this is creating a problem, but let's ignore that for now. And now what we need to do is that we added the structural framing, but we need to add this external plaster layer, finish layer to that. So again, go to plinth, and on that same rectangular beam, just go to architecture and wall, and with this plinth level base constraint, base offset 8 foot 6 inches, just wall center line and core center line, and just pick this. So now again we need to core face exterior. Yeah, so you see that it is wrapping that external layer of plaster. And again, let's go back to 3D, and let's first join the floor, the slab with that wall, and after that just HH, and we also need to join the wall with that column. Yeah, and now it's perfect. So only thing left is to add the structural framing to this particular face, and let's do that quickly. And again, we just need to go to architecture and beam, and with that constraint selected, just pick lines. Okay, left is not working, so right, that either is not working. Center, oh sorry, I selected center, it should be right, and pick lines. Yeah, okay, and let's go to 3D. Okay, plus HR, this AutoCAD plan. And first let's join the floor with the structure 1 and 2. Oh, thank God. Yeah, it perfectly joined. Only thing is left is to add the external layer of plaster, and that wouldn't be a big issue. So architecture, wall, and just pick lines and finish face exterior, and pick this, yeah, and just drag it all the way, and TR, and see, keep watching here when I say TR. So walls with walls, can't cut, you're going to create a problem for me. Let it drag all the way up, down, and yeah. And first let's modify and join that floor with that wall, and yeah, everything is fine. And after that, you also need to add the external layer of wall with that framing. So HH, and yeah, join, and join this with this beam. Yeah, fine, everything is perfect. So only problem is here, but that we would solve. And just press HR, and now if you see that we have one homogeneous slab and everything is perfect with no errors. And yeah, let's just sort this issue out. So we can just take it all the way here and take this. Okay, and yeah, we have sorted it out, but it has lots of connection over here. So we again need to bring it all the way to here. And yeah, so finally, okay, now let's not waste time on this, and let's forget this particular junction for now, because we have everything perfectly joined except this particular one column, but that's not an issue. And let's further continue with joining the flooring materials to this particular flooring slab. But the only purpose of just doing this whole work was that if I just go to plinth level and see this horizontal section, then this is the perfect anatomy, that what I wanted, that the slab should connect to the beam, and the beam should connect to the wall, and the external layer of plaster is wrapped in such a way that the structure is hidden. And if you want this beam to go switch order, and yeah, so anyways, while working on site, when this level comes and when the floor is casted, the reinforcement of this are overlapped, and the slab has been casted and also the beam, which is a simultaneous process. So it doesn't matter whether this is the joint condition or this is the joint condition. It depends upon the personal preference. Okay, so now let's, without wasting the time, let's start adding the flooring layers to this upper ground floor slab, and those are going to be micro units. So let me turn this units to mm for now, just as we did for the plinth floor slab. And let me just select this first, the upper ground floor slab, and go to edit type and go to edit, and let me insert a couple of layers. And this should be the brick beds, 100 mm, then is for waterproofing, and this should be 20 mm sand beading and 12 mm mortar, and finally the finishing material, which is going to be 19 mm. And with this, now you can see that your thickness is somewhere around 300, that is 1 foot. Okay, okay, apply, and let's quickly apply the desired material to that. And we have already defined that material, so we don't need to waste time on this. This should be brick beds, and this should be sand bedding, and this should be the mortar, where is mortar? Oh, sorry, gypsum plaster. Yeah, mortar. And finally this should be some different, so let's add some default, and let me just duplicate this and call this one flooring for upper, or let's say flooring for living room, and backspace and living room, flooring for living room. And let's go to asset browser, appearance library, and flooring. I'm just going to select any flooring for now, and let's add this and duplicate, and this should be one flooring for living. Let's change the styling to something like 1200, that is 4 foot. Apply and OK, and rest everything will be as it is, and just click apply and OK. And now you see that, let's see it in section, then we have added that extra layer of flooring to that particular level. But just like we did in this floor, we want this slab to be at this particular level, that is the unfinished level. So what we're going to do is that we're going to edit type, and let's sum up this external layers, that rounds up to 151. So we need to give it an offset of height offset of 151. That's fine. Okay, no issues. And you see that still, if I just drag this wall up, the external layer of plaster is covered, and you see that this flooring is, and this is the exact anatomy and perfect the way I wanted. Okay, so let's go to 3D again, and yeah, it's absolutely perfect, except for this particular, this should actually wrap up till here, but because of some problem it has not been able to. So let's go to upper ground floor, and let me just take this section. That is perfect, and just let me see that section, and you see that this layer is wrapping, but this is also wrapped, but it's not showing. So why is that? So let me just go to upper ground floor, upper ground floor, and let me just select this upper ground floor slab and just edit boundary. And yeah, that is because we have selected the external line, and we were supposed to select the internal line to show up that layer wrapped. So now if I go to 3D, yeah, so this is perfect. Okay, so now let's quickly create the water body slab, which is having a depression of 6 inch, not 6 inch, sorry, 1 foot. And we are going to create different layers of this particular slab. So let's go to edit type and edit structure, and and without wasting the time, I'm just going to call this the first layer to be brick beds, another one to be, let's say, the sand bedding, and the mortar, And finally the finished layer, which you are going to have some sort of tiles. So let me again create a different material, duplicate, and one water body tiles, copy and appearance, and go to asset browser and just select any random. Let me just select this and appearance, duplicate, water body tiles, and let's just change it to 1500. Oops, sorry, 1500, and done, and apply and OK. And this should have, we are going to just keep it 100 for now, and sand bedding again 40, so 12 mortar, so that rounds up to 152, and then this going to be again 12 mm tiles. Okay, so with that we have 316 mm of flooring for that particular water body, and let's just click OK, apply, and OK, and yeah. Now so let's go to section 2, and just as we gave this flooring an offset of 151, we again need to flush this slabs. So I need to measure this, how much is this from this end till this, 164. So this is 164, so 304.8, that is the thickness of the slab. That is the depression of the slab minus 164, so 140. So no, actually, yeah, so minus 140. Okay, in your elements doesn't matter. Yeah. So now this, you can see that the RCC slabs have at least flushed. There is a little 0.8 mm. So that is a 0.8 of difference. So minus 148. Oh, sorry. Minus 140.8. Yeah, so that will flush. So, okay. And while going to 3D, now we need to lay the layer of water at this particular end, this particular level. So again, going to upper ground floor, I'm just going to create a simple model in place, and generic model, which will be used only for applying the water material and extrusion, pick lines. I'm going to quickly draw that profile. Which could be used to show that here there is a water body, and while material, I'm just going to say water. Okay, and this should have 5 mm. That's enough, I guess. Just a small sliver onto which we can apply some material and differentiate it. Yeah, fine. And so you can see that now we have a water body, and we need to create the steps wherein we can place the furniture onto this particular water body. So going to upper ground floor and HR, and turn on the AutoCAD plan and create a couple of extrusions quickly without wasting a single second. And 1, 2, 3, It's going to pop up a message a couple of times. And we need to split 1, 2, 3, 4, and 5. Just delete this. Just a bit of a drafting work. Okay, and here too. And this main deck. Okay, and this is going to be, say, 0, and the work plane is upper ground floor, and we'll have a depression of, if you remember, let me change this UN and change this back to feet in fractional inches, and we're going to have a depression of, let's say, -6 inch, and the height of 6 inch. Okay, and that should have the material of duplicate and one wooden deck. Just going to appearance. I'm going to look for a wooden material, and let's say that this could be wood. And let me just select any. Let me just select this walnut. Appearance and duplicate. Paste of one wooden deck. Four feet by 4 feet. With the standard tile size. Just press finish. Okay. Finish. And yes, and let's go to 3D. Oh, perfect. So, okay, so we have our wooden deck floating on the water body, and the only thing is that I guess the extrusion should be 0. Yeah, but that will be submerged in the water, so this should have -0.5. -2. Okay, sorry, this should be -0.5 and -2 or -1. Okay, yeah. So we have our wooden deck floating on the water body. Okay, and let's just finish this. Now, one thing to notice is that right now we created this one homogeneous flooring, but if you remember that here we have the washrooms, toilet, and attached toilet and the common toilet. So this is again going to be a drop slab of 300 mm where the waterproofing would be done. But I suppose that while doing this you might have understood the logic that how can we provide a slab at different level, and how can we have a depression in slab and then cover it up while giving the floor finishes. And if not, then let's just quickly do it. So it will be a just good revision to this flooring and drop slab and sunken slab. Okay, so let me just finish this, select this and edit boundary, go to upper ground floor and let me just declines and deduct so much portion of this slab, and okay, TR, and delete these lines and create a slab. Okay, and it's fine. TR and join and don't attach. And while going to 3D, yeah, so we have deducted that much portion of the slab, and now we are going to create the washroom slab, toilet slab for that portion. And let's go to upper ground floor and floor and architectural and just edit type. Let me just select this generic 12-inch and then edit type and duplicate and call this one washroom slab. Oh, washroom slab. Yeah, that's okay, and keep the default thickness to 6-inch for now, and okay, and okay, and just draw this and pick this lines, TR and TR and TR. Yeah, fine. Okay, and just finish and don't attach. Okay, now let's go to 3D and see where did it created that particular slab. Okay, so now let's go to this upper ground floor and section 2. Yeah. Okay, so now this is again going to be a sunken slab which is going to flush at this particular beam bottom, so that should be given it's already -6 inches has been given, I think -12 inches. Yeah, fine, so that will flush and we will have inverted beam over here, and this is the portion where the waterproofing will be done. Okay, so if you just measure this, so this is 1 foot, that is 300 mm, but we have a finished floor of 75 mm, 150 mm onto that, the 6-inch 150 mm. So we have to give this particular sunken slab, design this particular sunken slab in a such a way and do the waterproofing in a such a way that here we will have not more than 25 mm at least. Actually it should be only one tile drop, that is 4 mm, 6 mm or 8 mm or 12 mm maximum, but we will have it 25 mm. Okay, so if I just now for just convenience here, let me just change this to sorry, that was distance. Let me just change this to millimeters and rounding up to 2 decimal places. Okay, we are going to work with micro units. So if you measure this, then it will somewhere around 455.80, and if we want one tile drop or let's say some round figure, then we have to design this particular drop slab in a such a way that the finished floor materials would end up somewhere over here where we would have only a level difference of 25 mm, 12 mm to 25 mm. So if this is 455, then minus 25, it will be 430 mm. So approximately we have to design this particular slab in such a way that we end up making 430 mm of finished floors. So let's go to edit type and 1 2 3 4 and insert, and this should be 300 mm, and that should be brick beds, and then we will have 100 mm PCC or BBC, sand beading, or in this case PCC because that is wash area. So 100 mm of let's select the sand beading, and then the 400 is done. So now 15 of mortar and finally 15 mm of the finishing tile. That would be, I will just select this existing swimming pool tiles. Yeah, fine. And now you see that we've rounded up to 582.40 and press OK. Yeah, fine. Apply and OK. And now you see that we want this particular beam bottom flush to this level. So this is 430 of the extra we provided. So we need to deduct that 304.80 minus 430, 125.2, 125.2. This is how we manipulate. And now you see that we have perfectly laid that drop slab, wherein we have this inverted beam which we can actually join, and we have here only this 25 mm. Yeah, that's 25.80. That's fine, perfectly fine. Let's go to 3D and see. Yeah, so this is the one tile drop between this flooring and this. Okay, so likewise we can quickly manipulate this particular floors, because yeah, so this is the hardscape. Let's go to edit type, edit, and 1 2 3 4, and this is again going to be let's say 100, and that should be brick beds. Okay, 20 mm should be the bedding, PCC, whatever you say. 12 mm should be the mortar. Yes, and finally the finishing material, 12 mm. That should be, in this case, let's define a different default, or let's just duplicate that wooden deck, and yeah, just duplicate, and let's say one wooden deck exterior, copy, and let's just go to asset browser and appearance library and flooring. Let me just select this, any of existing. I don't want base. Okay, and this duplicate and control V, exterior, fine, and this should be something like 1500. Oh, done, apply, okay, and okay, Y and okay. So you see that the flooring has changed. Okay, so likewise quickly let's create this wash area, wherein we are going to provide some sort of a tile. So again, 1 2 3 4, 100 brick beds, valid material. It is a valid material. Brick. This should be okay. That should go to something 20. 10 should be the mortar. And we will have a different tile, or let's not just duplicate these tiles, and let's say wash area tiles. Let's just give this tile and duplicate one wash area tiles, and 1200. Done. Apply. Okay. Yeah, give it a 12 mm thickness. Apply and okay. Perfect. And finally the grass garden material. So again the same process. Brick beds, sand bedding, 20, and this should be 12 mm mortar, and finally there should be some small sliver say 12 mm, and that should be grass. Yeah, fine. Okay, apply and okay. Okay, so with that, finally we have applied different materials to the slab by manipulating it differently. And the last step left is to manipulate this newly created floors. That is the one which we added the finishing material to position them in place to have a perfect step. So let's just go to edit upper ground floor, and let me just drag this section and look at the section. And if you remember that we have made this garden area a depression of 6 inch from this particular upper ground floor level. So we will actually manipulate it the same way we did for the toilet slab. That is, if we want, right now this newly added layers of flooring has been added to that 6 inch of slab, but we actually want to position this particular slab, which is right now 11.6 inches, at exactly 6 inch from this finished floor level. So let's just, for conveniency, let me just change this back to millimeters. And now if I measure this, then this is right now 296, and this height offset from this particular level for this particular slab garden area is 152.4. so what we need to do is that the logic is that we need to deduct this newly added 144 mm of finished floor layers from that 152, so that will position this particular slab exactly 6 inches down from this finished floor level. So 152.4 minus 144, that is 8.4. so this height offset should be minus 8.4. and yeah, so now you can see that if I measure this from finished floor level, it is exactly 152, that is 6 inches from this finished floor level. And that same follows for this wash area as well, since that is also 152.4 down, so minus 8.4. okay, and the only thing left is this hardscape floor, which is only 3 inch down, which right now says that it's minus 71.4, and the newly added layers are 144. So 144 minus 71.4, that gives us 72.6. okay, and now if you just go to this floor plan and click this section and just extend this view range a bit, such that you can see this floor finish of that particular floor, and again go back to section 2, then you see that the finish level of this particular slab is 159, that is almost 6 inch, that is one step, while this particular is 78, that is 3 inches, and that is what we exactly wanted. Okay, so this pertains to the garden area, and this is the wash area, and this is the hardscape floor, that is the deck, wooden deck, which is only 3 inch down, and this both are 6 inch down. Okay, so this is the way you can manipulate floors. Okay, and I suppose that it has been the same changes has been made for this particular deck as well. Yeah, 72.6. Yeah, so see how perfectly. Okay, and one last thing left for this particular floor plan is that we need the steps which would be leading from the parking level up to this upper ground floor. Okay, so let's just quickly do that, and for that I will go to plinth plan, but I don't have anything to reference to, so the AutoCAD plan is at upper ground floor. So let's bring that AutoCAD plan. Let's see if I change this underlay to plinth level, and yeah, so that AutoCAD plan is at above ground floor, so we need to go to 3D and change the constraint and bring it to plinth level. And now while going to plinth level, we can see that AutoCAD plan, and let's just press HH. And yeah, one important thing I wanted to show you is that right now if I just change this underlay to none, then you can see that we cannot see the framing, structural framing, that is the beam column grid, which ideally we show that what is happening on the above floor, we show it in dotted. So if we can see this, then why not make use of it? And let's just go to modify, and let me just select this invisible line, or sorry, not invisible, overhead line. You can create your own line style, but I'm just going to select this existing one, and let me just quickly take advantage of this functions of Revit, and let me create the beam grid, and let me show it, and that will perfectly appear in dotted in exactly this way we want to see it. And yeah, and this as well. 1 2 3 4. And now if I just change this underlay to none, let me just change this to none, then you can see that the beam grid is being seen. The only thing we forgot to snap to these two lines. And also this 2. And now if I just change this to none, then you can see that how beautifully you can see the beam grid. Okay, and now let's turn on the AutoCAD plan and quickly lay the staircase. And let me quickly go to architecture, and let's say stairs. And you cannot use this assemble staircase when we have such custom landing and custom profile of steps. So we need to go with monolithic stairs, which has the structural depth of that slab. I'll just show you. Edit type and just duplicate, and let's call this steps to upper ground. Okay, and maximum riser height 7 feet, minimum tread depth 1 feet, and minimum run width 3 feet. That's fine. We need to edit this run type, that is nosing, and call this duplicate and call this custom nosing, wherein we'll have the structural depth of say 6 inch, which will have this homogeneous slab of 6 inch casted along the entire stair path, and nosing length 3/4 of an inch. That's fine. And we don't want the risers to be slanted, we want it straight. And for the material, I'm just going to apply any existing material, and let's use that ramp material for this. And where is it? Yeah, ramp material. Okay, fine. And with this all settings, I'll just click OK and OK. And very importantly, now we need to constrain it properly. So I'll say that the base level should be plinth level and the top level should be upper ground floor. But if you remember that very important factor, that we are going to place this staircase on the finished floor level. Okay, and the finished floor level is something high than the the unfinished slab level. So let me just show you. If I just create sketch and pick lines, and I'm going to create let me just select this 1, 2, 3, 4 and 5, and these are the boundary lines. And let me just click risers. Also I need one boundary line over here which is not snapping to, so let's manually create it. And then risers, and I'm just going to pick lines, snap to lines 1, 2, and just select the lines from the AutoCAD plan. And with this I'll just complete the shape, trim the edges, and define the stair path, most important. Okay, so with all this settings, if I just hit the checkbox, invalid sketch, okay, and with this if I just hit the checkbox, you see that the staircase has been created, but it's going in the wrong direction, I guess. And yeah, so let's again go to plinth level and just select this text and say flip. Okay, fine. So if I go to 3D, then yeah, that's perfect, fine. And let me just first complete this staircase, and then we will change its constraint, and it's pop up some error message. So if I go to plinth level, and let's take this section all the way to here, and let's extend its range until we can see the full staircase. And if I just go to this section, then you will notice that the staircase is being laid at unfinished level, so we need to bring it to this height. So again, if I measure this, so I think we need to again go back to that micro units, millimeters, since we are going to deal with micro units. And now if I measure this, then the finished floor level is at 152.40. So what we need to do is that if we want this to be perfectly laid, let me just select this all and yeah, hide it. Okay, fine. And here it is 72.60. So let's calculate let's see the distance between the two finished floor levels. So this is the distance, that is 2968.20, some variable. That is the distance between the two finished floor slab levels. Okay, and if we want to lay 20 risers onto this, then 2968.20 divided by 20, that is 148.41, should be the actual riser height. So first what I'll do is just select this and give it a base offset of 152.40, and top level is 72.60. Okay, as soon as I enter this value, so you will see that the desired number of risers 20, it has changed its actual riser height to 148.42, and that's perfect. Okay, so now you see that we have the same riser height for all the for the entire staircase, and we are going completely from the finished floor of plinth level up to the finished floor of upper ground floor with the uniform riser height, okay, of all the stairs. So we just go to 3D and see this. Yeah, that's perfect. Only thing left is to add a flower bed to it, and again we need to go to section 3, and I want the flower bed at this height. Now this is something 1929.40. yeah, here we have a landing, so let's quickly do that. Go to architecture and wall, and again the base constraint to 152.40 and the top constraint to unconnected, and let's call it 2200. Yeah, that's fine. And let me just draw that wall. Core face exterior, that's of course center line. That's perfect. And likewise here also. No, but that's not. Let's change the location line in this case. Core exterior. Yeah, that's fine. And floor architecture, generic floor, 12-inch, edit type, duplicate, FB, flower bed. Okay, and let's just give it a thickness of let's say 15 and give it a grass material. Okay, fine. And it's constrained plinth level and the height offset of let's say 2175. And with this all constraints, I just check box and let's go to 3D. And yeah, you see, so we have made that flower bed as well. So now if you see that we have our staircase perfectly going from the finished floor level of the finished floor plinth level up to the finished floor upper ground level. Okay, and last but not least, what is left is to add the railings to this slab and here as well. So let's go to upper ground floor and let me say none. You can properly visualize the plan and we'll go to railing. Let's call it this glass panel bottom fill, edit type, duplicate, upper ground floor, railing. Okay, and just snap to the lines. Create, yeah, that's fine. And let's see it in section if it's placed properly. And to have a proper visual appearance, let's change this range level to this much. Okay, so now we have our railing properly placed. Okay, it doesn't have any problem. Let's go to 3D and see. Yeah, okay, no issues, fine. And likewise just place the railing for this slab as well. So railing again and just pick lines, finish it, architecture, railing again, and pick this and this, and yeah, it should be finished. So we need to create it individually. But here I guess we will have some height issues, and let me just check whether it is placed properly or not. So see, we need to give it because the finished floor level of this particular is minus 8.4. Yeah, okay, that's perfect. And likewise for ground floor, and just see this, and this should have an offset of 72.60. So 1 and 2 and 72.60. Okay, that's perfect. So now we are completely done manipulating this upper ground floor slab while segregating different areas, that is hardscape, softscape, water body, etc. Now we need to continue with the modeling part of this upper ground floor. So let me just take this AutoCAD plan back to upper ground floor for reference and change the preferred units, working units, to back to feet and fractional inches. And there's a very important feature of Revit that you can switch between working units, that is from real to metric and vice versa. Okay, so first is that let me just get rid of this other windows and have just this two window side by side. And if I just select this slab, then I need to get rid of this staircase portion before we can continue modeling with the modeling part. I need to get rid of that. So let's quickly do that. And oops, TR and F5, and just finish and attach. Oh, sorry. Finish and don't attach. Okay. So first we need to take all the structural columns up. For that, let me just hide this site, and also let me hide the levels category. And what is this? I need to change the constraint for this retaining wall. This 3 retaining wall, and that should not be bottom level but it's road level. Yeah, okay, fine. Now if I just drag this window and go to filter and check none, and let me just select only the structural columns, there are 19 of them, and okay. And with that selected, I will change that the base level to road level and the top level to first floor. And you see that our columns have come to that respective level. Okay, and so likewise, if I just watch here, if I just select this concrete structural framing, this beam, and press SA, and that selects all of the beams, HI, just to cross check. Okay, fine. Control Z, and again let me just select that concrete beam, SA. With that all selected, you can see that you have an ability to say copy to clipboard and align to selected levels, and I will want them at first floor. And this is how efficiently we have taken all our columns and structural beams and structural columns on the first floor. Okay, so now we can start the modeling part, that is construct the wall. That is, go to wall, and with the base constraint to upper ground floor and top constraint to first floor, core face exterior, the location line, since I want to add the plaster line, so you see that it automatically adds the plaster line. And let me just quickly draw that, and press space and press space, just doesn't matter, and just space. Likewise, I'm just creating some walls, I'll just join it later. Space, and yes, and likewise here too we have a wall, and this entire wall. Okay, and this point to here, and okay, fine. So also add the internal 4.5 inch thick walls. Oops, sorry. Wall, and ground floor, left look. Complete boundary. Don't attach. Yeah, fine. Wall 4.5 inch. Press tab. Yeah. All the way to here. Press to here, and I suppose this was here. Okay. Let's just finish this TR and trim the edges to have a close shape. Likewise this as well, and likewise this as well. Just take this wall all the way here. Yeah, and this as well. Okay, and here we have 4-inch thick wall as well with thick lines. 1, 2, 3, and just select and flip space and flip the direction and snap. And this too, I guess. Okay, fine. Also, we have some walls over here, but that is the main wall, I guess. 1 and 2. Okay. So see that we have constructed the walls of the upper ground floor. So how fast and how quick. Okay, the only thing left is that now again we need to join all the wall with that structural beams. So modify, join, and just stay tuned. Okay, so you can see that there are some beams which are not having that external layer of plaster, so we need to add that for. So let me just go to ceiling plan of upper ground floor, and okay, and let's go to wall and upper ground floor and base offset of, let's say, 8 foot 6 inches, and with the location line core face exterior, I'm going to select this point, flip the direction and join it with here. And where else? Yeah, this was that beam. Flip and join. Okay, but it didn't snap to properly. Yeah, the angle is wrong, I guess. So in such cases, just select wall and snap, flip the direction. Yeah, that's fine. Okay, and likewise here everything is perfect. Okay, we need to add beam here as well. This point and all the way to here. Okay, and it's perfect. Let's go to 3D And yeah, so just modify, join them all. Join. Okay, and this as well, and this as well. And this beams are left. And actually, if you just see the AutoCAD plan of this upper ground floor, and this is the first floor, and yeah, so here there will be no beam actually on this floor. So I need to just get rid of this beam, and neither this beam will not come. So let's go to ceiling plan of upper ground floor, and let's just quickly connect this here and take this all the way to here. Yeah, okay. And while going to wall and with the base constraint, upper ground floor, base offset 8 foot 6 inches, and top constraint first floor. And this time I'm going to use an alternate method. I'm just going to pick lines, and 1 and 2 and 1 and 2, and just select them, and wherever we have a problem I'll just click space and flip the direction of that, so that will perfectly occupy the space. Yeah, fine. So let's go to 3D and quickly join them as well. Okay, and let me check if nothing is wrong. Yeah, so this is left again, upper ground floor, and just architecture and wall, and just pick lines, flip the direction. Yeah, modify and join. Okay, so you see that with this how fast and efficiently we have created the masonry, the walls with the structural columns and structural beams, and the external plaster line of that wall wrapping around the structural elements. Okay, and don't worry about this particular area. We will go, if you just see this, and we will add that in the end, this little two sliver, which is the ventilation for toilet. Okay, we will add that later. We'll just take this wall all the way to first floor, or let's say terrace level. Okay, just join as well. I think we don't need this 3 beams as well at this particular floor. And also one thing, we need to add the opening to this wall for the entry to the kitchen area. So that I'm going to do here right itself in 3D. So just edit profile, and let me just draw a rectangle all the way up to the beam bottom, that is 8 foot 6 inches. And right now don't worry about its alignment in plan. It's going to adjust it later, and just split lines and connect this, and yeah, just finish it. Okay, and with this now let's go to upper ground floor, and let's see where that mesh has been created, and we can just drag it and position it properly. And yes, of course, this wall will also go all the way to this, and yeah. Okay, so with that, now let's start quickly without wasting the time. Let's start adding openings, that is door windows, to this particular floor plan. And let me go to upper ground floor, and let's quickly start adding doors first. Before that, let me just close this window and have this 2 windows side by side, so you can just see that while I lay the openings, what is happening in 3D. Okay, so I'll just go to architecture and door, and let me see that what doors do we have. And we have this double exterior door. I'm just going to select this existing door, and with that I'm going to go to edit type and just make sure that the width is 5 feet and the height is 7 feet. I want the lintel to be at 8 feet. I'll just click apply, OK, and add this door to this particular wall. Okay, and you see that as soon as I add this door has been added to that particular wall. Okay, so likewise, let's add the other doors of this. So this is going to be the interior, 36 inch, that is 3 foot. Edit type and just duplicate that and call this 3 foot 6 inches, and let's edit the width to 3 foot 6 inches, and height is 8 foot, that is the lintel. Okay, that's fine. And I'm going to add this door to the interior and just press space and flip the direction and add it. Okay, and we need one more here, but here we cannot add because we don't have a wall. So let me just drag this wall up to this end, and then again door and just press space and flip the direction and lay the door in your desired direction. And now architecture and door, and I'm just going to select this existing single flush door, and since I know that all the other doors are 2 feet 9 inches wide, I'm going to go to edit type and duplicate and call this 2 feet 9 inches, that is 33 inch, and I'm going to change this height to 8 feet lintel and the width to 2 feet 9 inches. And after doing these changes, I'm going to quickly press space and flip the direction 2, and one over here and one over here. And with this, now if you see that we have all our doors added to this particular 3D environment, what we just need to do is that align it properly. So we can do that quickly. So in this case, let's just modify, align, and okay, if it's not work this way, then just enter and move it manually, and in certain cases it will work and in some cases it won't. So this is fine, align, and yeah, so this is working perfectly. This is perfectly aligned, I guess, and this I need to flush. Okay, fine. So with this we have added the doors. Now let's switch on adding to windows, and that actually let me just go to windows, and first is the fixed window. So where do we are going to have the fixed window? So that is this position, the staircase block. We are going to have this fixed window, which should be actually 2 feet 6 inches width. So the height should be 6 foot 6 inches. That should round up to 8 feet of lintel, and the sill height as an instance parameter, we can change it after placing, and the width is 2 feet and 6 inches. Yeah, that's fine. And okay, and let me just place this here. Yeah, we'll align it later. And okay, that window is placed. Now next is again going to architecture and window, and for this particular portion I'm going to have this where do we have that? Yeah, windows double hung. Yeah, that's the window. I'm going to edit type, again duplicate, and call this 2 feet 6 inches, and for the width I'm going to enter 2 feet 6 inches, and height of course 5 feet. So we'll give it a sill height of 3 feet, and 5 feet is the height, so that rounds up to the lintel of 8 feet. Okay, I will add that one over here and one on this end. Okay, Don't worry about the alignment, we will align it once we place it. And for this window, I guess the sill height should be 18 inches, since the height we provided 6 foot 6 inches of height. Okay, now let's add the ventilation. So window, and let's go to this, where is it? Yeah, lowers, and it's going to be standard. So in this case, the sill height would be a 6 foot, and edit type, and I'm not going to duplicate it, and let's actually duplicate 2 feet. Okay, and the width is going to be the 2 feet, and the height, default sill height, the height is the instance parameter which you can change it from there, and the height to be 2 feet and width to be 2 feet. Yeah, that's fine. And let's just place it 1 and 2. Okay, this is creating an error. Yeah, that doesn't matter. Fine. Now let's add this particular window, and let's just assume that this is the south facade and we need a box window over here. So window, and let me just select that box window. Yeah, and if I just go to edit type, then yeah, its width is 5 feet and the height is 5 feet. Height, let's change to 6 feet. Okay, and okay, and I didn't duplicate it, but you don't forget to duplicate. And let's change the sill height to 3 feet. Okay, and let's just add that onto here, and we can actually make this width 6 foot as well. Yeah, sorry. So that will correspond to the floor plan. Okay, and now the next is that we need to add a sliding window over here, the kitchen portion. So where is that? Basement, double hung, and yeah, sliding. Yeah, this is that window. And just let me select this particular and edit type and duplicate and call it 6 foot, and the width is 6 foot. That's fine. Height is 3 feet. Lintel height, I need to change it to 5 feet, since we are going to give it a lintel of 3 feet. I want to match up to 8 feet of lintel, and with that, okay, let me just place one here, but this is not. Let me just measure the AutoCAD plan. Yeah, sorry, this is 8 feet. So edit type and rename it and call it 8 feet, and enter the width to be 8 feet, apply, and okay. Yeah, perfect. Now what we need to do is that add 3 sliding window onto this face, that is dining, which would be the entry to the deck on both the sides, and here as well one, which would be the entry to the balcony. And that sliding window will actually act as a sliding door. Okay, so how can you do that? But before that, I need to add this to walls. So let me go to wall and select that 4.5 inch thick wall, and base constraint to be upper ground floor and top constraint to be first floor. And I'm just going to pick lines with this core face exterior, the location line. I'm just going to pick the existing, and join elements, doesn't matter. Again, wall, pick lines, and okay, and we just need to select this wall and flip space and flip the direction. Okay, and the next is that modify. I'm going to split this wall and then connect this wall with this. Okay, TR, and connect this wall to this, and join elements. Yeah, it doesn't matter. And connect this to this and connect this with this. Okay, so fine. So what we need to do next is that before we proceed ahead, we need to join this newly added walls to the geometry, and for that I'll just go to modify and join geometry, and I'm going to select this main wall and I'm going to join geometry and hover until I find this rectangular beam and join it this. Okay, perfect. And likewise join this, and yeah, so everything is perfect now. The only thing that we need to add the external layer of plaster to this particular beam, and for that I need to go to this ceiling plan of upper ground floor and architecture and wall, and with that 9-inch wall I'm going to say that 3 base constraint upper ground floor and 8 foot 6 inch of an offset, and top constraint first floor, and this location 9 face exterior. I'm going to pick this face, and no, this is not working, so let me just try this. Yeah, okay, and that will add that wall. Okay, so let's go to modify and just join geometry, and again join this particular CC and R enter and join geometry. Okay, it's joined now. So now let's start adding the sliding window to it, which would actually act as a sliding door, which would be the entry to the deck in case of this dining on both sides and this bedroom. Okay, so let's go to architecture and window, look for that slider with trim, and this is going to be edit type and duplicate and call this 6 foot. Okay, and the height of this should be we are going to lay it on the finished flooring level of 6 inch. So to match the lintel of 8 feet, we need to give it a height of 7 feet 6 inches, and sill height is an instance parameter which we can change after laying that, but the width should be 5 feet 10 inches in this case. Since we have that slant wall, I don't want any conflict. Okay, and let me just place this. Yeah, so it's perfectly placed, and go to edit type, and this window is 10 foot. So just duplicate that and call it 10 foot, and every other constraint will remain the same except for this width will change to 10 foot. Okay, and let's just place that as well, and the last one, that is 8 foot. So edit type and duplicate and call it 8 foot, and 8 foot here as well, and let's add that as well. Okay, and now let's modify and align those windows in place. One, and this is perfect, no issues, and this as well. Okay, so TW, and let's go to 3D, and you will see that all of these windows which are going to act as a door should have a lintel seal height only of 6 inch. That is the finished floor level of that upper ground floor slab, and so now this will act as a sliding door and could be access to the deck, garden area, and balcony in this case. Okay, fine. So we need to add one more fixed window over here. So architecture and window, and where is the fixed window? Yeah, 2 feet 6 inches. Got edit type duplicate, call this 3 feet, and let's change that width to 3 feet, and okay, and just place it and modify and align. Okay, and let's go to 3D, and yes, of course we need to change the sill height, which is going to be 18 inch, doesn't matter. Okay, perfect. So what left is now to add the openings on this face, that is the north wall, and this is the west wall, since we are considering this as the south wall. Okay, so we are going to add curtain panels, the storefront system onto that particular two faces. So let me just go to upper ground floor and measure this, and this is 15 feet. Okay, and this is 10 feet. Okay, so let's go to architecture, wall. Let me go to the storefront system and just edit type and duplicate and call this storefront west wall. Okay, and the spacing should be 2 feet by 2 feet. And for the mullions, I'm going to select some smaller size and rectangular mullions, 1 inch, and copy and paste for the verticals and the horizontals. Paste and paste. Yeah. Okay, and with that, now I'm going to say that the base constraint should be upper ground floor, base offset 18 inch for the skirting, and the top constraint should be unconnected. And say if you want to match the lintel of 8 feet, this should be 6 foot 6 inches, and just draw one curtain wall. Okay, and likewise here, again wall, and edit type, rename, and this is going to be north. And with the same constraints, I'm just going to say okay, and I'm just going to change this base offset to the finish floor level 6 inch, and unconnected height to 8 feet 6 inch, 7 feet 6 inch, to match the lintel of 8 feet. And we have added storefront system on both the faces, and let's just see it. And yeah, so okay, what just we need a door over here. We could be access to this particular garden area, and just select this and say HI and select all of this, filter, and uncheck the walls, and with the curtain walls, grids, and mullions selected, just unpin them so we can just manipulate that particular geometry. And I'm going to delete some mullions from this. Also, I'm going to get rid of this grid. Okay, and this too. And select this 2 mullions as well. Sorry. Add, remove, and get rid of this grid first, and then this 2 mullions as well. And then just select this system panel glaze and change it to door, curtain, wall, storefront. Okay, and that could act as a door. HR. Okay, so with this, now you can see that we have completed the upper ground floor, adding all the door, windows, and openings to this. And only thing that we need to change this ventilation and change its sill height to a height of 2 feet, and match the lintel of 8 feet. We need to give it a sill height of 6 feet. And yeah, everything is perfect. Only thing is that this also, I think I need to give a edit, and yeah, the height should be 5 feet since the lintel is 8 foot. Okay, perfect. And this, everything is complete now for this upper ground floor. And quickly, without the wasting time, let's start modeling part of the first floor. And the first step is to construct the slab or cast the slab for first floor, for which essentially you can see that all this structural framing, that are beams which are the part of this wall, are being laid properly. But if I just take you to this upper ground floor plan, and if you just see the AutoCAD plan, then you will notice that on the first floor slab, we have this particular deck, and we have this projecting balcony, and also this projections for this walls. They've been laid differently. If I just take you to that particular plan, then you just see that this is the deck which is leading to the balcony, and this is the profile of the wall. Okay, so if you just right now just see 3D, then you will notice that on this particular floor, that is the first floor, we don't have that connecting beams or that structural framing which we need to add. Okay, so let's quickly do that, and for that let me just take this AutoCAD plan to first floor, and now let's go to the ceiling plan of the upper ground floor, and let's construct that beams. But you'll notice that the orientation and alignment of walls on the first floor is angled, and it's different from the floor below, so we need to be very careful. So let's just go to structure first and lay the beams, the structural framing, and this should be the placement plane first floor. Yeah, that's fine. And I'm just going to pick lines in this case, and let's just lay one beam. Okay, and that was perfectly joined. What we need to do is just connect it to this particular point. Okay, and we have a beam over here as well, so let's go to beam and again pick lines and select this and this and this. Okay, for this too, you can, or actually all three of them, just change the Y justification to right, and that will properly align them in place. Okay, so let's see it in 3D, and now we'll have to move carefully, slowly, step by step, while each time having a cross check of everything perfectly laid or not. And upper ground floor, and just connect this beam till its end. Okay, fine. So now the next step is to go to the ground floor of this, and we have taken the AutoCAD plan above on the above floor. So let's construct here only. So we need to add the external layer of plaster to this exposed beams. Okay, so let's do that. Upper ground floor ceiling plan and wall. And with that, if I just take this and let me just stop somewhere. Highlighted wall overlap one. So okay, doesn't matter. Let's just change this constraint to 8 foot and 6 inches. Okay, and just let's first join this, join wall with the concrete. Yeah, perfect. And this time it worked. And just connect this wall to this external wall, and not the structural beam but the main wall. Yeah, perfect. Okay, and it's perfect. The only problem is that here we have a little bit of problem, but we can solve that by just going to this upper ground floor ceiling plan and move from this point and snap to this point, and could pop up an error message, but that's fine. And just go to 3D, and yeah, it's unjoined, so we need to join again. But with that, now we have perfectly created that beam. Okay, so what we need to do is just add the external layer, wall plaster layer to the exposed beams. So that won't be a problem. So let me just show to, and just now we can hide the AutoCAD plan and just go to architecture and wall, and with that same constraints we can just yeah, perfect. So just come up till this point and this, and press space and this. Okay, and just TR and connect this and bring this all the way to down here. Yeah, so no, but we need to be careful. It's changing the orientation, it's changing the alignment, so you need to be very careful what you are snapping to. And this should actually snap to this line. Yeah, perfect. And let's go to 3D, and yeah, the only thing that it created the entire walls, but no problem, we are working with Revit, so that won't be an issue. So changing the constraint, now we have perfectly laid that, and just need to connect this, join this to this, and join this to this. Okay, and now we are perfectly done. Now I can say that the upper ground floor is perfectly completed, and now we can lay the first floor slab onto this particular thing. Okay, so let's quickly do that. Let's go to the floor plan of first floor, and again align the AutoCAD plan properly in position. So let's just align and select this face and select this face. Okay, and it's perfect. And let me just turn on the underlay to see that. Yeah, okay, so now let's first have a check. Okay, let's go to first floor and quickly create the slab for the first floor. So architecture and floor architecture, and this time I'm going to select this existing upper ground floor slab, and I'm going to edit type and just duplicate and call it first floor slab. Now this actually will be 75 mm of slab, it won't be 150 mm thick. So again you need to manipulate this layer, but I'm not going to waste time on that, so, and you can try that. Okay, so I'm just going to construct this as 150 mm thick, and let me just select this external layer and snap somewhere over because we have different orientations. So anyways, we want 2, 3, and okay, and this should connect with this. This should connect with this, and here we will have a slab on the top of this wall. So, and then this will connect with this, so but not that ways. We will have a line here as well. Okay, TR and finish, join this and okay, and let's quickly deduct the staircase and the toilet slab. It's just going to be this and yes, TR and TR and join this and join this to and this to this and this to this, and with this now let's just fingers crossed. Need to complete this line. Yeah, finish. One more, and finally, and we have this line. And yes, but we created, where did we create? Yeah, we created, okay, we created the offset of, and that should perfectly align with the floor now. And yeah, so you see that the floor has been created and it's absolutely perfect, except for the thing that now we need to join geometries. And let me just hide the AutoCAD plan and let's quickly join the geometry. And so now again you need to be a bit patient and just stay tuned until I complete joining all of this. And we don't have anything to reference, so for reference I will just take this on attach. And yeah, and now just be patient and follow, and I could just quickly clear up this and join the geometries. So 1, 2. Okay, so we do have problem at some junctions, but I don't think that it's ideal to waste time on that now. And because of the orientations of the wall and angle junction, it's quite obvious that we might have snapped to some wrong line while drafting. So let's proceed ahead further with this first floor slab, and let's complete it while adding a drop slab over here and the 2 balcony slabs. Okay, so before that, let me just select this, and this should actually directly connect with this. Okay, and yeah, don't attach. Okay, fine. And at least this works. Okay, fine. So the first step is to create the structural beam and the framing for the balcony portion. Okay, so again, let's go to first floor and structure and beam, and let me create this quickly. I'm going the placement plane is first floor. Yeah, that's fine. And we are in the first floor, so not an issue. But where did I add the framing? Yeah, that's perfect. So let's go to ceiling plan of upper ground floor, and yeah, just turn on the underlay upper ground floor and look down. No, the range level first floor. No, but where is the AutoCAD plan? Yeah, fine. So just select all of this and change its right justification to right. Okay, disconnect this too, and likewise beam, and just select and right. One and this line 2. Okay, fine. And let's create the wall as well, and that should go at 8 foot 6 inches. And with exterior, just create 1 and 2 and 3. Okay, and likewise here. Press tab and yeah, highlight the ball overlap with the metal. Okay, so modify and join geometries. Oh, this is a big critical problem. These two are joined, but this is not. Yeah, fine. Snap to the wrong. This with this. Join, and this with this. Okay, that's fine. And we forgot here. We have one more here. So for ground floor and structure and beam. First floor and architecture and wall. And let's just pick flip and 3D and just modify and join. Yeah, that did work. So sometimes it does, sometimes it doesn't. So it's okay. So let's go to first floor and let's add that 2 floors, that 2 slabs, floor architecture, and just going to select that FB. Yeah, and you can just snap 2 lines, 1, 2, 3, and 4. TR And likewise here, let me just change this 0 and change this range level. Oh, we are in the floor plan. Oh, just 1 and 2, 3 and 4. Finish. TR, TR, finish. Or attach. That's fine. Now let's go to 3D. Let's give it a different material for proper visual appearance and just duplicate it. Call this balcony. And edit type. And let's go to and use some existing material of wooden deck. Okay, apply, okay. And yeah. Okay, perfect. And likewise this also. Done. Okay. And finally this sunk slab. So first floor, and then we're going to say that architecture and floor, and we are going to lay the same washroom slab onto that. I'm just going to pick this rectangle. Just finish, don't attach, 3D, and yeah, see, perfect. So just modify and join. One element is completely inside the other. Join, at least let's join this first. And join. So okay, fine. So it's very important that what do you snap to. So this is not joining, but that's not an issue. Let's try. Okay, just forget it, and let's proceed ahead with the constructing walls of this particular first floor. And I guess that on the upper ground floor, I think we have an access to this deck. So let's just quickly do that first. And upper ground floor, and I don't need the reference of AutoCAD plan. I just lay the slider with trim 6 foot for now. And yeah, okay. And along this entire deck, let's just add wall and let's say piece of glass. Let me just select the exterior glazing and upper ground floor and 0, and this should be unconnected with height of 3 foot. This 6 inch. Okay, fine, and just snap 1, 2 and 3. Okay, and let's see it in 3D. Yeah, okay, fine. So this needs to be lintel of 6 inch, and that could be the entry, the door to this deck. Okay, fine. Now let's take this opening at its desired location, which we just used for reference, and this is that face, I guess, first floor, and yeah, not opening, cut out. Okay, fine. So now let me just select the side HH, and we are going to follow the same process, filter and check none, and for now just the structural columns. Okay, and with that selected, take the top level constraint to say terrace level. Okay, now from this particular level, just filter and check none and select the structural framing and OK, and with the selected, copy to clipboard and paste to align to selected levels, and I'm going to take that to terrace level. Okay, perfect. Now let's have this 3D and the first floor plan side by side, and from that we can make out that what would be the grid of this particular terrace floor plan, and it is quite obvious that this particular beam won't be needed at the terrace floor level, so I will just delete that, and this we would need because that is the family sitting, and this would also be needed. And yes, the very obvious thing is that these two columns will stop at the upper ground floor, so let's change it to first floor. Yeah, and neither we will need this beam nor we will need this, neither this. Okay, so with this little bit of obvious changes, let's start with the modeling part and let's start constructing the wall. The things will get more clear. So let me go to first floor and let me quickly construct, say, walls, and this time I'll say that I want the base constraint to be first floor and 0 and base offset to be terrace floor. Yeah, and with the location line, not exterior glazing but the main wall, and the location line to be the core face exterior, since we again want that wall thickness, the external layer of plaster to be wrapped, and 1 and 2, and this is always a problem, so let's just click this point, and yeah, let's add somewhere to here for now, and likewise let's continue adding from here all the way till this point, and from here till here. Let's stop somewhere in the midway because there's a problem of snapping to the lines, so many lines, and let's add here, and likewise let's again stop here, but this is not laid properly. Let's suppose no, so see, it's not laid properly. So wall and just underlays on a what? No, so just flip and select this and let's add up till here, and then let's connect this to okay, TR and TR, okay, and we need the internal walls onto this, but before that let's add this till here and this till here, and likewise this wall, yeah, this is there, so wall and internal wall 4.5 inch, yeah, okay, so connect that with this. Oops, here we don't have a wall. Okay, fine, wall again and the main 9-inch wall, and that will go all the way to here, and that will connect with this, okay, and wall again this point, and we'll stop here somewhere, and we'll continue from here again from this particular portion where we have the door. That's fine. And for the angled wall, I don't want to take chance, so just pick lines and flip the direction. Sorry. Yeah. So connect this with this. Okay, perfect. And a lot of unnecessary lines we are seeing. Let me just HH this AutoCAD plan. And why are we seeing this beam grid? So let's go to the underlay, yeah, see, none. And now turn on the AutoCAD plan so we can properly visualize, and wall and 4.5 inch, the lines, it's going to be this and this, of course. Okay, let's take this all the way to here so we can wrap the external layer. This would stop here. Okay, fine. And yes, wall and again the 9-inch wall, pick lines and just pick this and just flip the direction by pressing space and take it all the way to the edge of the column, and likewise just take it to here. Okay, fine. So I suppose that we have done everything correctly, and let's add wall and a 9-inch wall, but this time I'm going to say that unconnected, and let's give it a height of 3 foot and just pick lines I need to act as a parapet wall. Okay, and let's see it in 3D. And yeah, perfect so far. Only thing that we need to give the external layer of plaster with the exposed beam and also connect the masonry with the structure. So again, it is going to be, so this two beams and this beam, this beam, this beam, all of this. So let me just go to the ceiling plan of first floor, and where I don't find the wall with external layer, just first floor and 8 foot 6 inches. And yeah, let me just add, oops, core face exterior is selected, so let me just connect, but this is again not snapping perfectly. Let's select this. Yeah, so this does 1 and 2. And we'll have beam here as well, here completely from here up to this end, I guess. That one overlaps. Let me just take it to, yeah, up till this point only. Fine. See it in 3D. Or this will, it's added with the wrong constraints, I guess. Oh, sorry. Not unconnected height, but go up to terrace level. So that will position it properly. And as I said, this I guess should go up to here. So let it take it all the way to here. It is supposed to be to this end. Okay. And then in that case, yeah, okay, till this end. We have a door over here. So we need to add one internal wall here as well, since we will need to place a door. So that should go from first floor to terrace floor. And yeah, just connect. Okay, fine. Okay, perfect. And what left is that we need to give the plaster layers to this beams. So let's start from here, and wall, and again 8 foot 6 inches and up to terrace level, and core face exterior. Okay, sorry, not 5.9 inch. One and yeah, here. Two and this, 2, 3 and 4, 5 and 6. Oops, too fast. Sorry. Wall and pick lines. Flip the direction. And where are we left with? Okay, this beams, so wall and pick lines, and this I'm just going to pick lines. Select this and flip space and flip the direction. But actually, this will not come, because here we will have on the terrace slab we will have a parapet over here. So this entire portion will not come. Let's get rid of that and all of this. And yeah, now I suppose that, and this two structural members still remains. So let's go to first floor and wall and pick. Okay, and this column is wrapped, so not an issue. Let's give it a height offset of 8 foot 6 inches. So, and this one is also left. Wall and pick lines, and but that should have 8 foot 6 of an offset. Okay, and yes, this beam will go all the way till here, both structural framing and the wall. So just select this and drag this point all the way till here, and likewise this concrete rectangular beam all the way till here. Yeah, and this one over here. And yes, okay, so now it's time to join the geometries. That is the masonry with the structure part, and this is going to take a bit of time, so just stay tuned and just follow. Just modify and join. Okay, and I suppose that I have perfectly joined all the structural elements to the architectural masonry elements. Okay, so next is that we can actually turn this into a railing, not wall, but let's just select this exterior glazing. Yeah, that's fine. Definitely we'll have some reinforcement, some 6-inch of skirting over here, but right now I assume that you know that. Okay, so and now we need to add openings, that is the door windows and ventilations, to this particular first floor, and that would not take much of time since we have all our openings, heights and dimensions and everything established, done for this particular upper ground floor. So we're just going to reflect the same. So let me just go to the upper ground floor, and let me just first start with the doors, and this is going to be the 4-foot door. So let me just select that, 3 foot 6 inches. Yeah, flip and add, and the rest are going to be, yeah, here one. Yeah, it's going to be this swing. The AutoCAD plan shows the wrong swing. And then is the single flush 229, and that's going to be part of this here and here and here, and one for the balcony. And for balcony, let's put some this exterior double door. Yeah, Okay, and let's change to wireframe so you can see the openings. AutoCAD plan, and now let's start adding the windows. So let me go to window first, and the fixed window is 2.6, which will come here, and the double hung 2.6 over here, and this is going to be the ventilation. So, and one over here, and the slider with trim 8 foot, sorry, 10 foot, sorry, slider with trim 10 foot, no, it's 8 foot. So let's place one here and one here, and the ventilations for this 2 feet and one over here, and yeah, it will have only one since it's one toilet. Just for the sake of elevation treatment, let's add 2. It doesn't make sense, but and one over here. Okay, and let's align them properly. Align, and this should be here, and then we have one over here as well. Access to balcony and architecture window and slider with trim 6 foot. Let's add. Okay, and wall and this piece of glass exterior glazing should act as a railing, and the constraint to say 6 inches, and unconnected 3 foot, and let's just pick lines 1 and 2. Yeah, that's fine. Don't want to go all the way to here. Okay, and what left? Okay, so this 3 windows, this 3 slider with trim, there's 1 and 2 and 3 mats need to have a still height of 6 inch. Okay, so perfect, and this should go at sill height of 6 feet. The ventilation and rest, everything is fine, no issues. And also we can add the same window here. So let's just select this and copy to clipboard, align to selected levels and first floor. And yeah, so see how efficiently we can work with Revit. And just as we added this particular glass railing, which just has hanging on the air somewhere, and let's give it 0. Okay, fine. Let's add here too for the balcony, and the first floor and railing, and this time I'm going to select authentic railing for this glass panel bottom fill on first floor, and just pick lines and 1, 2 and 3 is finished, and 1, oops, railing, and pick 1, 2, and 3. Let's see it in 3D. Yeah, perfect, no issues. And now we are going to add openings for these 2 walls on the first floor. That is, for this particular north wall, I'm just going to add a simple sliver of opening, which would be just an opening for the intake of light. And here we are going to continue with the storefront system. So let's just quickly do that. And while going to first floor, I'm just going to click for wall, and I'm just going to select this curtain wall 1, or let's say just a piece of, yeah, that's curtain wall 1. And I'm going to edit type and just check on automatically embed, and with the base offset of 5 feet, yeah, that's fine. Unconnected height of, let's say 3 feet. So I'm just going to randomly, without taking any reference of any AutoCAD plan, none of the create elements available for you might have to. So it is created, but where was it created? So yeah, it is, yeah, fine. And yeah, it's created, but we cannot see it. And let's make it a little bit, yeah, and unconnected base offset to 6 foot, so that would match the lintel. Fine. The purpose of this particular piece of glass is just that, for the intake of light. Okay, and now we are going to take this particular storefront system. Since it's the same surface and same wall, I'm just going to manipulate this storefront system in such a way that it will cover up this entire this floor as well. Okay, so how we can do that? Just go to upper ground floor, and yeah, now let's just select this curtain wall and let's isolate that. Now I'll select any of this particular mullion, and right now you see that if I go to edit type, then it has this parameter offset. I will just take this right now, that it's positioning exactly in the center, and we have a 9-inch thick wall, and its own thickness is 1 inch. So I'll just give it an offset of 5 inch. Apply and OK. So that will take all the mullions 5 inch away from that center. And if you just measure this, then the distance from here to here is 4.5 inch. Yeah, that's perfect, fine. And I will select the system panel glaze and go to edit type, and this is right now, you see that the distance is 2 inch and its own thickness is 1.5 inch. So when I select this particular, so you say that it's offset of 1/4, I'll just add 4.75, that is 3/4 of an inch to that, and make it 5 inch as well, and just click apply, and that will embed. Yeah, okay, so now this is okay, and just press HR. Now what you can do is that you can go to the first floor plan and exactly have an underlay, or let's just first select this particular wall, edit profile, and let's go to 3D. Now we are again going to work in 3D, and HL, and let's create an opening which would randomly just, yeah, doesn't matter, and just delete this line. Oh, sorry, not delete. I'll just take this line 6 inch up, exactly 6 inch up, and the lintel should be 8 foot. Oops, sorry. And this should be 8 foot. Okay, fine. And we are creating an opening for onto this, or cutout in this particular wall. And how can we comply that, and how can we make it correspond to the opening on the lower floor? So for that we need to go to and turn on and change the underlay to upper ground floor. So now we can see that here this is the opening gap of 15 meter. So we can just select this wall and we can snap this opening to this particular, that will comply and correspond exactly. Okay, with that, now if you go to 3D, what you can do is that you can select this storefront system curtain wall and change its top constraint to, let's say, something like 25 feet. Okay, and 25 feet is too much. Let's change it to 18 feet. And 16 feet 6 inches, I guess. And let's just try, yeah, oh, it's snapping to the line. Okay, so that is how you can create an entire opening. And with that, now I can just go to edit type and change this grid to, let's keep it 5 feet by 5 feet and apply and okay. Yeah, and if I just change this to realistic, then you see that you have this curtain wall placed. And what you can do is that you can select this system panel glaze and go to edit type, and the glass material, you can just select any other glass, and we can just duplicate this glass and call this black glass, and appearance, duplicate that as well and change its color to gray, or let's say custom, and that color to something darker shade of gray. So that would be something like this. Yeah, okay, apply and okay, apply and okay. And you see, this is how you can manipulate this particular opening. And if you want, you can reduce the grid size to something like 4 feet by 4 feet. Apply and okay, and have more grids, and you have your structure hidden. And what you can do for this particular beam is just give it an extra layer of plaster. And by now I know that, and by now I hope that you know how to do that. Okay, so that is how we have added openings to this first floor as well. Okay, and now it's the time to come to the terrace floor level. So let's first construct the slab for terrace floor, and by default for that you need to press HR and take the AutoCAD plan on the floor, terrace floor. And let's just close this, we don't need it anymore, and let's go to terrace floor, terrace level plan, and just by default VG and important categories, turn it to halftone and align the plan at the preferred location. And let me just check underlay, and has it aligned properly? And yes, it has. So now just change this back to none, and quickly let's create architecture and floor architecture. And this I'm going to select let's say upper ground floor slab, and delete and duplicate and call it terrace floor. Okay, and everything will be same except for I'm just going to apply a different material to this, and just duplicate and call this one terrace floor, and copy and give it a different material. I'm going to asset browser and appearance library and site work, and let's just select this, any of this. Yeah, okay, and just duplicate that and call Control V terrace floor and image, and that's 4 feet by 4 feet. That's perfect. apply and okay, and yes, and let's just quickly create the terrace floor plan, and we need to pick lines and pick 1, 2, 3, 4 TR and join TR. Let's just delete these lines and quickly 1, 2, 3, 4, 5 and 6 and close the slab. Okay, and let's just also delete the staircase portion. And in that case I need to delete this TR and okay, and let's quickly finish. Oh, yeah, don't attach and 3D, and that's perfect. Okay, so right, perfect. Without wasting the time, just let me just HH this AutoCAD plan for now. Also HH the site, and let me just quickly join this. And this time I'm again going to take this out for reference. Don't attach and modify, and just stay tuned. I'll just quickly complete that. Okay, so we are done with the terrace floor, and let me just again take this back to its desired location, terrace level, and snap it. Okay, don't attach. Yeah, that's fine. And now let's go to 3D, and I need to select few columns. So let's select all this and filter and check none, and let's say the structural columns. Okay, and let's change that from road level to slab top. Okay, and I suppose all these columns we don't need, so change it back to terrace level. And yes, now we need to go to the ceiling plan of terrace level and change underlay to none. Upper ground floor, no. And now we need to go to the ceiling plan of terrace level, and yes, structure and beam, pick a plane, yes, terrace slab top. Okay, and quickly create the grid, and with that justification to right, and let's just one, oops, with that justification to center, I guess 1 to 2 and 2 to 3 and 4 and 5 and this one as well. Okay, we just need to align it properly. So modify and align. This face to this and this face to this, and just TR and close the shape, TR and close the shape. Okay, and align. Okay, and take this all the way. Okay, let's see it in 3D, and yeah, fine. So again, go to terrace level floor plan and let's create the architectural walls. And this time I'm going to select the main wall, 9-inch, base constraint terrace level, base offset 0, and top constraint slab top, and top constraint slab top and top offset 15-inch for the pardi, and finish face core face exterior. How efficiently and quickly and fast we can work with Revit. Use TR and yeah, fine. And one last wall. 1 and 2. Okay, and let me add a door. Oops, door, and just this existing one for the storeroom, and one over here. Yeah, you can align it. Okay, that's perfect. And let's go to 3D. And yes, oh, the only problem lies here. We created a center left, actually right. No, then the wall might be, let's see the AutoCAD plan. And yeah, the wall is in place, so the structural framing needs to be aligned and it's aligned properly. Okay, that's fine. And yes, we will have beam over here. Sorry. So this would stop here, and we'll go to architecture and beam, and we'll have a beam over here. Okay, 3D, and that's perfect. Okay, and let's finally go to select top and complete the shape. Floor. Yaar. Architecture and floor architecture and terrace floor. Yeah, that's one and the same. Fine. Just a complete boundary, close shape, and finish. No attach. Let's go to 3D, and these two walls shouldn't have the offset. And modify join. Okay, and terrace level and architecture wall and the base constraint and unconnected 3 foot for the parapet, and just going to select 1, 2. Okay, flip. And that has added the parapet wall to the entire terrace floor, you can see. Now let's add the covering slab to this two chajjas, overhead chajjas. So let's go to terrace floor, and let me just say that floor architecture. And actually, instead of providing a chajja or slab, what we can do is that we can give it a slope glazing. That would more. So go to roof and yeah, slope glazing, and just select this 4-face TR and complete the shape, and likewise here as well. 1, 2, 3 and 4, complete the shape, and select all of this and uncheck define slope and finish. This sketch defines more than one footprints, yeah, so we cannot add two at a time. So let's just finish this first, and then again architecture and roof, and sloped glazing and pick lines. 1, 2, 3. Complete the shape. Define slope and check, and then let's go to 3D. And what you can do now is that select this tool, HI, okay, and let's start adding grid to it. Okay, so slope glazing, edit type, and just duplicate this since you're going to customize it. And let's say that you want the grid 1 fixed distance of say 6 inch. Okay, and because of the orientation is appearing something at slant, but doesn't matter. What you can do is that slope glazing 2, you can just try out this grid 1, let's say 15, yeah, that is the one. Let's say 8, yeah, that's fine, not an issue. And likewise for this, and this for, let's select grid 2 in this case, 6 inch, apply and okay. Yeah, but okay, doesn't matter. And just press HR, and yeah, select this sloped glazing and give it a depression of -6 inch. No, that's too much. -2 inch is fine. And let's have, for the mullions, let's have the rectangular 1.5, copy and paste, apply and okay. Did it add? No. Paste, sorry, yeah, okay. So likewise the same, select this sloped glazing and do it a base offset of 2-inch, and edit type, and in this case we will have this grid 2, copy and paste, yeah, apply and okay, perfect. So okay, so let's move further and just hide this wall. Yeah, and since you know that we have not added openings on the parking level, let me just select all of this for now, copy paste and align to selected level and copy them to plinth level. That's perfect, no issues. Okay, and this will go above also. Actually, this is the staircase block and we can actually manipulate it the same way like we did for this particular curtain wall. And let's just do it for one wall and then we'll just copy it. So let's just delete this and hide this wall and edit profile, and again HL, I'm going to draft in 3D. So let's keep a random opening, give it a random opening and just finish it. And yeah, you need to manipulate it height, and that should be 8 foot 6 inches, the lintel, and the top should be 18 inches, and this I guess is this is 1 foot 6 inches, so yeah, so the 6 foot 6 inches we want to meet. Oh, sorry, 6 foot 6 inches if we want to reach to the lintel. Okay, and fine, and just finish this. And then what we can do is just go to that plinth level plan, and right now we can, yeah, this is that particular thing, but we don't have anything for reference, so let's just assume that this is that. And now from 2 feet 6 inches from here, so for that I think that we need some reference plane and move it 2 feet 6 inches. Okay, and just snap this. Perfect. Now what you can do is that we have perfectly placed that in position, so just get rid of this wall and this wall and also this wall, and let's just copy this wall, copy to clipboard and align to selected levels and place it on upper, first and terrace level. Fine, and see how perfect. Join geometries. So what we need to do is just join those geometries, and yeah, now what you can do is that just as we did for that curtain wall, just go to that plinth level and the wall, exterior glazing from base level, base constraint plinth level under the base offset of say 1 feet, and top constraint to, let's say, slab top, and top offset to be minus 18, minus 2 feet, yeah, that's fine. And let's add okay, just move it. Let's see it in 3D. Enter. Yeah, that's fine. Okay, so this should go all the way to this. Okay, and this is where we have added an entire glass to that stair cabin by giving the cutout to that wall, and likewise what we can do is just give it a mullion, so that will make it more realistic. Okay, fine, and edit type and give that mullion material, let's say cherry. Okay, fine, apply and okay, yeah, that's perfect. And likewise we need to add this window to both the floors, so again copy to clipboard, align, paste to align selected levels, and we need to add it to plinth level and of course the terrace floor. Perfect. And also we need some window on this portion, so let me go to first floor, and yeah, we here have a window but we forgot to place it, so let me just place this fixed window existing 2.6, and yeah, just one here, and let's go in 3D. Yeah, that's fine, but give it a offset of 3 foot, and I don't want it to be a large window, so just duplicate 2 and height of 5 feet, and yeah, okay, yeah, perfect. And just copy that, copy to clipboard, align to selected levels, and also to first floor, sorry, also to terrace level. Perfect. And this window should also be there at this plinth level, upper ground floor, sorry, not plinth level, yeah. So this is how we have manipulated this entire 3D, this entire house, villa. And now the last thing left is to add a sloping roof to this. Let's do that quickly. And once we add the sloping roof to this particular face, so the construction of these two walls will change a bit. That is the structural elements, that is the structural framing, the beams will also change, and also the openings on both the face will change. So we will get to know once we add it. So let me just go to terrace floor level and add a sloping roof. So let me go to roof and edit type and duplicate and say custom roof, and give it a, let's consider the basic thickness, slab thickness of 6 inch. Exact size again will be decided by the structural engineer. And I'm going to give this a new material, call it one roof material, and I'm just going to select any existing concrete for this particular slab, and let's select this let's select this casting green. Yeah, that's fine, and just duplicate that as well, and one roof material, and yeah, that's fine. Sample size, let's turn it to 15, apply and okay, and let's just draft it out. So pick lines, we have some lines to which you can use as a reference. Okay, and I'm just going to select all of this and uncheck define slope, and I will say that I want slope only at this particular end, since I want to have the gradient from this end to this end. And also if this is the overhang, what is the length of the overhang? See, something 6 foot. So let's have some cutouts in this particular overhang. So let's quickly do that. Or offset of say 2 feet, and yeah, offset of 1 feet, and let's pick these lines 1 and 2 and offset that 6 inches. Oops. Offset that and offset that 6 inches, or let's say 9 inch if we are not wrong. Then let's just close this shape and define and check define slope for this particular set, and likewise offset 2 feet from this end as well, and then offset 1 feet and offset 9 inches, since we will have a beam running through this entire edge, this edge. Okay, so let's have this 2 lines and uncheck define slope, and these 2 lines I don't need it anymore, and let's just CO and copy it from this end till this end. No, but that would be too much. Let's move it here. Pop up an error message, doesn't matter, and let's move it 1 feet. Okay, that's fine, and just copy it multiple times, 1 and 2 and 3. Oh, the last one was copied wrong, but that's okay. Just copy all of this. Okay, and just copy all of this, CO. Okay, and likewise this end. Okay, that's perfect, and just copy this end to this end. Yeah, and then just CO copy 1 and 2. Okay, and then copy all of this, CO from this end to this end. Yeah, that's perfect. Okay, and just finish this. Let's see what happens. Okay, and just go to 3D, and whoa, we have our sloping roof, but the slope is, so let's just press UN, and so if I just scroll down, then the slope is 9 inch object 1 inch. So just press UN and make the slope, turn the slope degrees, and okay, and the desired slope is 20, I guess. Yeah, that's perfect, and let's give it some offset of say -5 feet. Okay, yeah, so as I said, now we need to change this wall a bit, and for the first step is that let's select this concrete structural beam and go to terrace level and take this all the way to this edge, and we snapped it to wrong location. Yeah, doesn't matter. And likewise select this concrete beam, hover until you find this concrete structural framing, yeah, and then snap it back to this edge. Okay, this column, and fine. And now what you need to do is that lower this curtain wall, and that should probably go something like 12 feet down, and that could be actually 13 feet. That's not a problem. Okay, and just edit this profile and snap this wall to that height and just finish it. Okay, and what you need to do in this case of what you need to do in case of this opening is I guess you don't need to change this particular opening, that's fine. And this is one concrete beam again, which needs to be, but that is so yeah, just snap it to the correct location. Okay, and with this, now what you need to do is go to terrace level and take this wall all the way till this edge. Fine, and take this wall and attach top base and select this roof. Perfect, and select this wall and attach top base and select this roof. So you have a column which you can also attach top base and snap this particular roof. Yeah, that's fine. Okay, and this is way how we can add a sloping roof. The only thing what we need to do is that we need to take this wall a bit high, something like 8 foot 6 inches. 8 foot 6 inches. Yeah, that's fine. Okay, you can just manually adjust to match the size of the roof. Okay, and what to be done in this case is we also need to close this particular thing. So what you can do is this: go to architecture component and model in place and select a generic model and have a custom extrusion and just close this shape. Okay, which I'm not going to waste time on right now. Okay, and what you can do is that now you can add a skylight to this particular sloping roof, and for that I need to go to Windows and let's see, and yes, we have that skylight. Just place it, okay, and that is placed, I guess. Yeah, okay, and you see that we have a see-through. So you can flip the direction as per your design. You can flip the orientation. You can also go to edit type, duplicate, and customize this and have this your preferred width and preferred height, all the instance parameters. 6 feet by 5 feet is fine. Yeah, okay. Apply, and yeah, see. Okay. Parametric component it is, so that will adapt to any size. Fine, so this is how we can create a sloping roof, and let's just turn on the shadows and let's see the play of light on this particular structure. Yeah, okay. And one thing left is for this particular 3D model is that I need to add the internal staircase. Just as we added the staircase from the plinth to upper ground, I will just want to show you that how efficiently and fast, if you are working with Revit, you can lay the staircase. And for that, I need to just turn on this AutoCAD plan and turn off the shadows so that we can work properly. And let me just take this to plinth level so we can have something to reference. And I'm going to just Yeah, this is that particular block, staircase block. I'm just going to hide this wall such that we can see the staircase block properly and what are we modeling. And that should basically go from plinth level up till the terrace floor. Okay, so let me just go to the plinth level plan, and you see that now we have the AutoCAD plan on that as a, which you can use as a reference. And I'll just click staircase, and I'm going to use this cast in place steps to upper ground, and I'm just going to edit it and duplicate it and call it internal staircase. Okay, and the minimum tread depth, just change it to 10 inches, and rest everything is fine. I'll just click OK. And very importantly, I'm going to change the constraints here, that I want the base level to be road level and base offset 0, and I want to go to all the way to terrace level. And the, oh sorry, no, not terrace level, but upper ground floor. Yeah, fine, with top offset 0. And yeah, the desired number of staircase, since the AutoCAD plan says that there are 20 of them, so I want them to 20, and it will calculate, manipulate that ways. And the actual riser height is greater than the maximum riser height specified in the, okay, so again the maximum riser height, let's, yeah, that is fine, but it's going from not road level, sorry, plinth level, and that would have the staircase height, the desired stair height 10 feet, and the desired number of risers should be 20. So that will change the actual riser height to 6 inches, and for residential staircase, that's fine. And actual tread depth, since I know that this AutoCAD plan has the tread depth of 11 inches. Now I'm just going to say run, and I'm going to run, and you see that as soon as I run, it says that so many risers created and so much remaining. So 10 risers created, 10 remaining, and I will just draw it here. And sorry, let me just click undo, and yeah, and for run, the actual run width, this is 4 feet wide, I guess. Yeah, see, so it is 4 feet wide. So run, and the actual run width, the instance parameter 4 feet. And now, yeah, let's just 10 created, 10 remaining, fine. And we need to adjust it a little bit, so that is not an issue. I can just select this and move it to the desired location. Yeah, no issues. And this as well, move, and fine. Okay, and this we need to convert to sketch bay. Edit sketch and snap it to perfect location. Likewise here as well, and this should go here. Okay, at this point, okay, that's not important. And let me just finish. Okay, and finish, no problem. And let's just go to 3D and see. So absolutely perfect and no issues. And we have our staircase going from the, but the only problem is that if I just take this section, and let's see the section, and take this section here. Yeah, so yeah, okay, so we need to elevate it to the finished floor levels, and here also you can see that there's a problem. So that's not a big issue. Just give it a base offset of the finished floor level is 6 inch and at both the ends. So that will, yeah, perfectly place it. And you see that you have the uniform riser height for all the steps and going up to the first floor. Now what we can do is that just extend this, and I
think I need to change the material for landing. Yeah, I don't want it to be concrete, but I want it to be the same, and that should be essentially the ramp material. Where is it? Yeah, okay. Apply and okay, and apply and okay, fine. And with this, now you can just select the staircase and say, actually the railing as well, the staircase and railing, everything. And with all that selected, just copy to clipboard and align to selected levels and say upper ground floor, first floor, and that will take up to the terrace level. Yeah, so okay, so you see that you have laid your internal staircase so quickly and so fast. Okay, that's perfect, with uniform riser height and no issues, no problem. Okay, let's just click HR, and again let's go back to 3D and take the AutoCAD plan to first terrace level. Yeah, but actually there is nothing left to do with the terrace level now. Okay, fine. Now let's add some site components to this particular architectural model, just to make it a bit realistic. And yes, now this architectural model looks quite realistic with all the site component added, that is the trees, the street light, cars, the human figures and everything, which is nothing but the existing library of Revit. And also in the description you can find this couple of links which provides the library for Revit. Some of them are paid and some are free. You can just download and explore it on yourself. But the point is that this basically pertains to the phase 1 of architectural segment of this course, Master Diploma in Revit. Okay, and the next is the parametric modeling, and I'm going to just give you an overview of the phase 2 parametric modeling and the phase 3, that is the visual scripting. Okay, so and let me just show you that while working with Revit, you have an ability to switch between various options. And this architecture model has 3 options. There is the basic Revit, which you are right now seeing. Let me turn it on to parametric modeling. And you see that this entire facade, this particular surface has changed. And let me just show you some functions of this particular parametric modeling. Okay, and if you just see that, let me just turn off the shadows, and you see that right now this is the step, this parametric step, the line base family, and you have an ability to manipulate this and edit it as per your design. And you see that you can change the steps of depth, the height of steps, and the width as well, and just apply and okay. And you see that has changed. Okay, you can edit all the parameters related to this particular parametric step, which is line based family, just to make it a bit realistic. Let me give it, yeah, that's fine. You can just play around with it as per your design, and you see that you can edit it in the way you want. Okay, so this is one component. The another is this roof, which earlier was just a concrete slab. Now you can see that this has this tiles, this Mangalore tiles or Spanish tiles, whatever you call this, and you can also manipulate this as per your design and as per your configuration. The exact size of the tiles you can change as per the availability in your neighborhood. And let me just show you that. You can change this to
40 and this to 40 as well. Not 4 but 40. And you see that it has calculated and laid that tiles that ways. Okay, so this is not anymore now the concrete slab, but it is a sloping roof with that tile. Okay, so next is this openings. Okay, you can also edit this opening as per your design, and let me show you some features and functions of this parametric component. Okay, so when I select this, it says that the sliding folding door, and you can see some instance parameters connected to it, which I can just change, and you see the changes being reflected. Okay, and likewise you can just select this and go to edit type, and as per your design you can make any changes. That is, I will change few numbers and few parameters, and you will see and the changes will be reflected here, and you'll be able to see that. Let me change the overall width to something like 12 feet, and let me change the sliding folding width to 8 feet 6 inches, and let me change the transom height to 18 inches, and the overall height to, right now it's 7 foot 6 inches, let's take it to 8 feet 6 inches, which is the lintel in this case. And with all this changes, if I just click apply, and you see that the changes has been reflected in the design, and it can adapt to any size and any height. And the most important thing about this parametric elements 3D models are that you can use it from project to project with a few alterations, and once made you don't have to make it again and again. And you see that all of this are this parametric doors and parametric components, the height and width of which you can edit. And just as you have this centrally pivoted door or for this particular 3D model, you see that for this particular 3D model you have an off-center pivot door, and which you can change, edit the height, width and everything. Let me just show you the height to, let's take it to the lintel level 8 foot 6 inch, and the width to, let's increase it to something like 10 feet or 8 feet, and the transom height to 2 feet. And with these changes I just click apply, and the changes will reflect in the 3D model. Okay, and let me just, so this is an off-center pivot door, and likewise you have this parametric window which you can edit few numbers and have a different configuration and different results every time. So let me just change this height to 7 foot 6 inches, 6 foot 6 inches, since we have a lintel of 1 foot 6 inch, and this bottom pane to, let's say, 2 feet and 6 inch, and okay, fine, and the width to 8 feet, that is fine. You can also make it broader. Let's make it overall width to 10 feet and the transom height to 1 feet 6 inches. And with this few numbers change, you see that those changes will reflect there. And yeah, see, if you want the equal division of this particular window, then there is a parameter which will make this window symmetrical. Yes, so this is how you can
manipulate this particular window and have a different result every time as per your design and need. So that basically pertains to the phase 2, that is the parametric modeling. And finally, now the last part is phase 3, that is the visual scripting. And actually for this particular model, I have no face or no wall left wherein I can show you the application of that. So I'm going to use this particular compound wall wherein I'm going to show you the application of that visual scripting. And we are going to manipulate this particular wall and in Dynamo, and this is that. Okay, so we have basically selected this particular compound wall, which I'm going to edit, which I'm going to manipulate in Dynamo and show you that how can we use the scripting language, which is altogether a different working interface. And for this, you can say that the sky is the limit, and we can have infinite options for a particular design, and there is no end to it. So that I'm just going to show you. So let's see that. Let me just preview this on. Yeah, so you see that automatically turn on the preview, this has created that particular geometry over here. So basically it is nothing but just a wave wall created with this, using this scripting language, of which you can have infinite options until you are satisfied with the design, and the change in few numbers will reflect the change in design. Okay, so I'm just going to show you that you see that as soon as I enter few numbers, that will give a different result. And that has reduced its depth. Okay, so I'll just take it to what it was. Okay, and likewise you can manipulate this particular design until you are satisfied, and once you are happy with the design, what you can do is just connect this node to this particular import instance of geometry, and just connect this particular node to import instance by geometry, and that particular your design will be reflected in the 3D interface. Okay, so this was all about the 3D architectural model. And Revit is not only about modeling the 3D interface, but it also does model the 2D interface. That is, let me just show you my existing another project which I have did, and you see that we can schedule and quantify everything in Revit. That is, this is the area schedule, and this is the door schedule, and this is the floor schedule with its total cost and description and area and everything. Whatever information you enter into this particular interface, then that will model that particular thing. Okay, so that was all about the architectural segment of this course, Master Diploma in Revit BIM, the next session of which we are going to start from Monday 6:30 p.m. sharp. And if you are interested, then kindly enroll for the course, and let's learn together and let's grow together. Thank you and bye.